Oh, you should check with Dawn.
You're not that tall. Okay. Get some lights in here, maybe.
I'm expecting to hear back, so I'll let you know. Just say hi. It's just because if we do it in the morning, it will be long asleep, right? So I just want to make sure.
Why are there no lights on the front here?
Ja, dat dat is het. Dat is het.
By the way, I had a question. So I had a talk yesterday, right? And one of the questions was, would Aura work with the EDA? And the answer is yes.
In what sense?
So, EDA receives events, eventually triggers a playbook. The playbook ends up being recorded. It works,
of course,
right?
yeah.
And as a bonus, what we found out is that EDA
Hello, hello.
See, a bit loud, maybe. Say something.
Hello, hello, hello.
That's okay.
Hey.
When we take the questions, do we want to give them the mics?
Yeah, we can. We have this mic here.
Or I can repeat the question.
Yeah.
Yes,
That's what we did last year.
yes,
Yeah.
that was the
Works
best.
better.
That was the best.
It'll pick it up from there, but this is easier.
Yes.
I'll be in the other room for a bit, and I'll be back here.
All right.
Thank you.
Thank you, Mark.
No problem. You should be set up, so should be fine.
We'll start in 5 minutes.
Yep. Whoa.
You want it's a problem. You can just be like, this is what we're doing at the moment. You've got more people, and I've got like 3 people, so there's not much anyone else. I've got social rows, but I'm doing it another room. Yeah, it's 5:40. 5:40.
Yep.
Welcome everyone after lunch. Are you all well fed? Okay, great. So before we start the afternoon session, before that there is one announcement to make. In the other room, other Ansible room, we are going to have this story stitch session for the Ansible community at 5:30.
Nice.
It starts at 5:30. So please be there and be a part of the community. And now for the first talk of the afternoon session, it's automating hybrid clouds with event-driven Ansible. So how many of you know event-driven Ansible?
Oh, wow. Okay.
Okay, great. And so hybrid cloud has brought its own challenges in the modern IT infrastructure, and we can, of course, have a solution with Ansible. And how? Now, Ricardo is going to talk to us and take us on that journey. So, welcome, Ricardo. Ricardo is a principal software engineer at Red Hat. So, Ricardo, the stage is all yours.
All right. Hello, everyone. So, welcome to this talk. As Anwisha said, automating hybrid clouds with event-driven Ansible. A little bit of introduction. So, yeah. So that's my full name, but everybody calls me Ricky. You can do too. Just my wife calls me Ricardo when she's angry at me, so that's why, I jump when I hear, Ricardo. Yeah, principal software engineer at Red Hat. I've been at Red Hat for 7 years and a half now, almost. Yeah, pretty happy. I've been doing different things within the company. I'm right now a member of the productization team. We productize the Ansible offerings. Namely, what we do is that we take all the dependencies and all the action projects that make AAP, we package it, we make it installable, and that's basically what we do. So we're responsible for doing the packaging, container images, the installers, and we are also involved in the cloud offerings. Previous to that, though, so I was heavily involved in OpenStack. I was working at HP for a long time. Then joined Red Hat via Ansible engineering. That was my first stint at Ansible. Then did some stuff with OpenShift engineering and the CTO office, and now I'm back at the mothership. And I'm pretty happy to be back, to be honest. So, mandatory slide, I hate to do this, but yeah, what is hybrid cloud? Everybody will have its own understanding, its own definition about what it is. This is just a copy paste from the Red Hat website. Refers to a combination of at least 2 computing environments to share information, yada yada. In the end, it's just, hey, I have multiple clouds for running my workloads. There may be in public clouds or in private clouds, maybe edge, whatever, it's the latest, hype term for clouds these days. They can be bare metal, virtualized, that doesn't really matter. It's just that we have multiple clouds for running our workloads, and that's about it. So why so many people use hybrid cloud, and why it's so popular? I think, it has some advantages. First off, it provides a migration path from on-premise to public. So a lot of companies, they want to move to the cloud. They have an old, rusty data center with servers that they haven't refreshed in a while. They want to move to cloud, but it's not as easy as do a lift and shift. So hybrid cloud allows you to just do baby steps and move the things that you can move to public, and then some other things are still on-premise, and then you can just iterate. You can use it for public cloud scale. If you have a need for a lot of compute, a lot of networking, obviously on a hyperscaler like AWS, Azure, or GCP can help you to just provide that scale. Data protection and compliance, that's also another advantage. So not every company or every organization can just move to the public cloud. There are like data sovereignty and compliance issues with, especially with data that you cannot possibly just move to the public clouds, and they need to live in on-premise in a certain location. So with hybrid cloud, you can have some stuff in public, some other stuff, for the data that you cannot move, can stay on-premise. And also mix and match of best public cloud offerings. I don't know, maybe you have some AI, cool thing, and you want to use OpenAI within Azure, and you can use Azure just for that, but some other stuff, maybe you have an HPC workload and you want to run that in a bare metal on-premise. You can really mix and match and just use, what's better for the workload in question. So disadvantages, so not everything, is rosy and cool and everything. Management. So with more clouds, with great power comes great responsibility. You have many more things to manage. So, multiple clouds, multiple repositories for infrastructure provisioning, how you can, different web consoles, it's a different entry point for each one of them. Skills gap, it's actually rare to find people who are versed in both public and private clouds. Those are kind of like unicorns, because you typically find AWS experts, OpenStack experts, VMware experts, but having someone who knows, I don't know, AWS, GCP, and OpenStack, that is difficult. Also, another disadvantage or challenge, security. Access control. You need to take care about more things, so it's easier to have something to slip through the cracks, and have a hole in the security of your applications, since you have a more scattered infrastructure. And cost, because you have more things, it's actually difficult to do the cost management and the cost tracking. I don't know about you, but in every single organization that I've gone, it's always we've always been pinged months after, oh, we have this VM or this resource that has been used for months. Nobody knows what it is about, and has been killing the cloud build. So that's actually super typical. So what can we actually do or use to actually ease or the pain points or the challenges of hybrid cloud? We can use automation, right? It's not a silver bullet, but it's something that taking the human factor or the ClickOps and the fat fingering from the equation, it can actually help. So what can we actually use for the automation? I'm biased. Obviously, I work for Ansible. I like it. So I think Ansible is a great tool for automating stuff. I'm going to give a couple of bullets about what it is. I'm assuming that you all know it, but I don't like to presume things. So Ansible is an IT automation tool. It's open source. You can just download it. You can look at the source code. You can adapt it. It's very easy to learn and use. It uses YAML. It's very readable. Agentless, meaning that you don't have to install anything on the target system to actually connect them or manage them with Ansible. You literally just need to have Ansible in your laptop or in a central server, and from there you just control your systems. And it's highly extensible with plugins. Pretty much everything in Ansible is like a plugin based, so you can very easily change behavior or functionalities by just plug-in and plug-out stuff. So what can we do with Ansible? We can do config management, the typical stuff. So configuring your servers, your users, installing packages, files, templating, that kind of thing. Infrastructure provisioning, we can do provisioning of the infrastructure that is going to hold our workloads, whether it's on-prem or in public clouds. I mean, it can actually help us. I mean, we can use to provision stuff in AWS, in GCP, in Azure, but we can also use it for doing bare metal provisioning. We can use Foreman integration or Cobbler or something like that. We can also use it for application deployment. So once we have our application package somewhere, we can just use it to roll out the application, whether it's containerized, non-containerized, package-based, we can just use it. And the last bullet, this is actually my favorite one, is orchestration. Because Ansible tries to play nice with everything and with everyone. We try to just integrate with everything. So you can actually use it to even use Ansible to actually do a Puppet apply, for example. And there are integration for pretty much everything. So you can use it as a universal language to glue your automation. If you have multiple different tooling and systems, you can use it as the common layer for doing the orchestration. So yeah, the pillars or the areas that you can use it for. So hybrid cloud, the matter of this topic. So we'll go more into detail in the next slide. Networking. So we have a specific team within Ansible just for networking. So they develop and maintain modules for managing routers, switches for pretty much every vendor. Cisco, Arista, Juniper, a lot of many different things. We also have obviously partner modules for networking as well. The same for security. We have modules for, we used to do development of that stuff. I believe we still maintain, but I'm not sure. But we also have modules for firewalls, CMs, and that kind of thing. We can also use it for the edge, IP term right now. So how can we use it for private cloud automation? So as I said, so we have collections. So a collection is like a package. It's like you can think of it as a container for Ansible code for automating a particular topic or area. So we have collections for automating AWS, for automating Azure, for automating GCP. What they do contain, so they contain modules, plugins, and inventories to manage the automation. So you can create VPCs, VMs, security groups, firewalls, databases, I don't know, LLMs, that's, are very popular these days. You can think pretty much everything. And even if there's no specific module for a particular resource that you need or have to manage, you can use the orchestration service of the pertinent hyperscalers. So for example, in Azure, you can actually use ARM, Azure Resource Manager, so you can actually create a template with the resources that you want to manage, and then you use the module for ARM to basically push and have everything in one go. The same for Google. So for the Amazon collection, we maintain it. So we have the cloud team actually develop and maintain that collection. For the Azure, it's actually Microsoft maintaining that, and for Google, the Google folks. The same. So for private clouds, we have the same. So we have also collections for most of the private clouds software out there. So we have one collection for VMware, another one for OpenStack. We also have for Kubernetes. Again, it contains modules, plugins, and inventories to manage all that. So actually, Ansible develops and maintain, I think it's VMware and Kubernetes, and OpenStack, I think it's just the community. That's actually not maintained by Ansible. So having said that, I don't want you to take that we just support that. I mean, we have a vast amount of collections and modules for other stuff. To name a few, so I know that there are modules for Vultr Cloud, for CloudScale, CloudStack, DigitalOcean. I think there are many different out there. I'm just putting the most popular ones that I can think of, but there are many more. So we have the hybrid cloud. So we have collections to manage public clouds. We have collections for managing private clouds. So we can use Ansible and AWX or AAP Controller, which is actually the commercial version of AWX, to automate your IT infrastructure from a centralized system. Oops, we died. No.
Switch. Yeah.
No. Is that good? Yes. So that's cool. So we have automation, which can help us to tame or ease the pain and the challenges of hybrid cloud. But it would be better if we had like a way to actually put on autopilot the automation. So rather than waiting for issues to appear or to occur, to imagine, I'm not able to access this application or this server. Typically, you get a ticket, and then you go, you do your debugging, you figure out what it is, and then you find the problem, and then you check whether there's a playbook or a job template to actually fix the issue. Now, it would be good if there was some sort of a hands-off automation for that, for the most common things. It would be great if we had a mechanism to basically listen or get information from our systems and react to them and hooking them up into our automation. So basically, automate even further, connect the events from our environments to our existing automation. And that is exactly what EDA is trying to achieve. So event-driven Ansible, acronym EDA, it's an Ansible project that allows you to execute automation based off events. To me, that's at least in my mind the best and the shortest way to define it. it allows you to automate the triggering of your Ansible automation. So rather than being reactive, you can define, it allows you to define what conditions you want to trigger your automation depending on what's happening in your environment. So how it does that? So it observes events from your environment, then it catches those events and is going to evaluate those events against some rules that you define. And then depending if there's a match on those rules, you may or may not want to do something about it, because obviously there may be events that they're like meaningless and they're not worth your attention, but there are things that you may want to just do something. So that's where you hook it up to run an action when there's a rule match. So this is kind of very vague and abstract, so let's see how is actually, how does it look like in practice. So this is a rule book. So what is a rule book? So as you probably notice, it's close to a playbook. So yeah, we call it rule books. So rule books are EDA playbooks. So they're similar to playbooks, but how they differ. So playbooks is it's a bunch of tasks that you will just go and execute subsequently. You can have conditions, but it's like top to bottom, right? With a rule book, it's more of a if this then that flow, in which you define the source of events that you are interested in. You define the rules. Okay, so I'm listening events from this source, and hey, I want to create some rules for those events coming in. You define the conditions for those rules, and then if there's a match, then the action gets executed. So if you can see in this example, it's a kind of a hello world kind of thing. So the Ansible EDA range is kind of like a dummy or debugging kind of event source plugin that we ship. It basically will just create events in a loop. So in this case, it's going to create an event from 0 up to 4, and it's going to create an event object containing an I key with the value of the iteration. So then in the rule, we're saying, okay, so if you get an event in which the I key is equals to 1, then run the playbook Ansible EDA hello. So what's going to happen? So the first event is going to be 0. Is going to try to check the condition for the rule. Is event.I equals 1? No, because it's 0, then it won't do anything. Then for the next event, 1, then it's going to evaluate to true. Then it's going to execute the playbook. So it will run Ansible EDA hello just when basically the event is 1. So this is actually not super exciting, but hopefully the next example can give you a brief idea of how this can actually be helpful and cool in your environments. So here we're using a different source, URL check. So that's an event source plugin that allows you to specify a list of URLs. So what's going to do that plugin? It will go periodically. I think by default it's every minute, but don't quote me on that. And it's going to ping those URLs. And it's going to create an event and return as part of the event the status code of that HTTP request. So what this rulebook is actually going to do. So it's going to, every minute, is going to check 1111 API v1 have check every minute. If there's any time that it's not going to have a 200 as a return code, then it's going to run restart app. So this is basically a self-healing rulebook. It will allow you to restart your web application in case you cannot have a 200 at any given point in time. So rulebooks contains a set of uniquely named rule sets. So rule sets you can think of, the way it helps me to actually picture in my mind is to, it's the same as a play within a playbook. A playbook can actually have a series of plays. So a rulebook can have a series of rule sets. So it's the same. Rule set may contain a host to target the automation. As you probably notice here, you have here a host line, right? So that's actually only it's only relevant in case you're using either a run playbook or run module, because it will actually run the action against the inventory that you pass to rulebook. But if you use, for example, something that we're going to see in the next slide, to actually run a job template against an AWX, the host is not really important because the inventory is actually tied to the job template. So it's not really relevant. The rules contain conditions and actions, as we said. So if the events match the conditions, then the rule action is going to be executed. So it's going to check events, check events, check events. Oh, a new event popped up. I'm going to evaluate the event to the rules. Okay, so what are the conditions for each of the rules? There's a match? No, pass. If there's a match, then execute the action. It's actually, a simple concept. So you can have multiple rules, define a rule set, so you can have like multiple things that you want to evaluate. Each rule can have multiple conditions. You can use Boolean logic, so you can use and, or, is, whatever. For a more comprehensive list of what you can do as part of defining the conditions, I recommend that you go to Ansible-rulebook, read the docs.org. It's actually a pretty good documentation. And each rule can contain multiple actions, which will be executed sequentially. So in the examples earlier, we have just one action, but you can actually have actions. And you can have like a list of things that can be executed, in sequence when there's a rule match. Yeah, so as I said, Boolean arithmetic and is operator for individual statements. You can have like multiple conditions. You can have any or all. You can actually have like a list of conditions and say, hey, please make sure that if any of this, is true, then execute the action. Or you can have like, hey, I want you to basically have all the conditions to evaluate to true to actually go to the action. So you have a lot of flexibility there. And yeah, so the actions is the final part of the event-driven flow. Is actually the payload. It's actually what it does something once there's an event and there's a rule match, what you want to do about it. It defines the execution part. There's a built-in set of actions bundled with EDA. So we saw a couple of them in the examples. So you can actually use run playbook. So you can have like a playbook alongside the rulebook, and then just use something. You can literally run Ansible rulebook on your server, and you pass the inventory, and you pass you have a playbook within the same folder. So when there's a match, you can have like a run playbook like we saw in the examples earlier. Run module, the same thing. Run module is equivalent to Ansible-M, and you pass the module name. So rather than having to create a playbook to actually do something, you can actually do like a quick one-liner to run some action. So as I said, so there's also run job template and run workflow template. So that's actually to integrate with either AWX or AAP controller. So if you have an AWX and you have job templates or workflow templates, you can actually hook it and run it, whenever as a part of an action. There are some other things that can help you to have more complex rulebooks, like creating facts as part of the rulebook, post events. So events, are available down the line, retab facts. But probably the most useful ones will be run playbook and run job template, because hopefully you will either be using plain Ansible or AWX. So as we saw earlier, EDA range and URL check, those are event source plugins. They contain the business logic for the sources. So that's actually like Python code. They're similar. You can think of it like Ansible modules, but for EDA. So whenever you want to, you're interested in, imagine that you want, I don't know, you have a system, some application, some special device, and you want to listen to events about the device. So you would actually write an event source plugin that would plug into that device to get the events. So that's basically how it works. So the event source plugins can either be polling or listening, meaning you can have an event source plugin that can be polling an external system for events, or you can have the external system to send events to a port, and the event source plugin will actually process it. So how does it look like? This is actually more how to develop an event source plugin. I'm not a particularly great Python developer, especially with async.io. I've been using Golang for a bit the past few years. But as you can see, this is basically the payload of the URL check plugin. It's just an infinite loop in which, hey, is going to go through each one of the URLs that you have as part of the parameters that you pass to the plugin, and it will try to connect to it, and then it will put it into an async queue with the status code. So actually, yeah. This is actually I should have explained this earlier. So we ship the official collection for event source plugins is actually called Ansible.eda. So that's the collection that we develop and maintain within Red Hat. What it contains. So right now it has like a bunch of things. I think these are the ones that they're most useful and probably relevant for the hybrid clouds environment. So there's an event source plugin to Kafka. So you have an event source plugin that can actually subscribe to a topic into Kafka, and whenever there's something coming into the Kafka queue, it will actually consume it. So Alert Manager Prometheus, same thing. If you have an application used in Prometheus, an Alert Manager, you can have Alert Manager sending events to EDA to actually process them. CloudTrail, so I'm not sure if you're familiar with that service AWS. That's actually like the API logging system for AWS. So whenever you do something with your AWS account, you log in with the user, you create a VM, you change a security group. So all that is constantly being logged. And you can actually see those events in that service that is called AWS CloudTrail. So you can use that event source plugin to plug into a CloudTrail trail and basically get those events, consume those events, and then eventually do something about it. So SQS, that's a message queue service from AWS. That's actually the oldest service from AWS. I think it was launched in 2006. So it's basically just a queue that you can send stuff, and then you can consume as they come along. Azure Service Bus, it's similar, but I think it's more akin to SNS. It's more of it's not a queue. I think it's a fire and forget kind of thing. And webhook. So that webhook is actually a good one because it's a very versatile event source plugin. Reason being, because it's very easy to send a post request with a JSON payload, and pretty much everything these days, any web service allows you to have like a webhook. So anything that you are using that allows you to send webhooks, that is something that you can consume with a webhook event source plugin. So those are the things that they're part of Ansible.eda. But we also have partners, helping us out. CrowdStrike is a security vendor, I think it is. So they have their own event source plugin, so you can actually plug into CrowdStrike for security-related incidents in EDA. Cisco and X1000X, they also have another thing, Dynatrace, which is actually very popular in monitoring. Instana, Turbonomic, also on the monitoring area, I think. Palo Alto is a security firewall vendor. F5 the same. Zabbix networking system for managing networking devices and such. So as part of getting an event, you also have the capability of like filtering the event. So maybe you don't want to just send this straight away to the playbook or the job template, the whole event, but you want to actually like filter the event before create some sort of a pipeline, and then you can send it. You can think of it as like the Jinja filters in Ansible. So this is fairly similar. They can be changed, and they allow you to transform data from events, and that's it. So these are some of the event filters that are available. You can filter with JSON. I think it allows you to pass a JSON query to actually mangle the thing. Also, convert dashes to underscore. You can also play with the host to put into meta. That's probably just useful for run playbook. You can also normalize keys. So how EDA content is distributed? So as we said earlier, there's Ansible.EDA. So we are piggybacking on the collection concept. So Ansible EDA event source plugins will be shipped and delivered as Ansible collections. And therefore, you can just use the same tooling. So Ansible Galaxy collection install and to install an EDA collection. As a matter of fact, so Ansible EDA, so you would do Ansible Galaxy collection install Ansible.EDA to get the Ansible.EDA collection. So what EDA is, what are the components? So you have Ansible Rulebook. That's actually, it was the first upstream component for EDA. It's the CLI and worker component for event-driven Ansible. You can actually do a pip install Ansible-rulebook, and you can use it from your laptop, from a server. You don't need to be in Kubernetes or anything. You can just use it straight away from the command line. Because it allows you to run as a standalone mode. You do Ansible-rulebook, -I inventory, -R my rulebook, and it runs on the foreground. It also allows you to run in working mode, to connect it to a WebSocket. That's probably not super useful. That's actually something that is actually leveraged by the EDA server that we're going to go through in the next slide. So EDA controller, the same way that we have Ansible and we have AWX. So AWX is like a central web application for actually managing Ansible. So EDA is the same idea and the same concept. So you have a controller. So it's a web application with an API and a UI, so you can actually centralize your rulebooks, activate your rulebooks, all that. I remember last year that we did a quick demo, and we were asked, I think it was you, David, hey, this is cool. So you have the EDA server. Is this upstream? And we kind of blushed. No, we don't have it yet. So 3 weeks ago, we upstreamed it. We were working on it because it was actually green. So meaning you can actually just go there and you can install EDA server operator the same way you install AWX operator in your Kubernetes cluster, and you have the same functionality that you have in AAP, bar, support, and whatever. Okay, so Ansible for helping us automate our hybrid clouds, EDA to putting autopilot our automation, but how can we actually, mesh them together to, automate our clouds, AWS, GCP, Kubernetes, whatever. Here I'm giving some ideas with the things that we have right now as event source plugins. I'm not going to lie to you, we don't have a massive amount of event source plugins, so we would welcome contributions in that part. But there are ways to circumvent that, the lack of vendor-specific event source plugins. And I go through it, right now. So for AWS, as I said, so I'm going to have to rush. So we have CloudTrail event source plugin, and we have SQS. So with CloudTrail, we can actually plug to a CloudTrail trail and get events from that trail, consume it into EDA, put our rules, and run our actions. But that's just one service. It's CloudTrail. So you cannot do something like, for example, oh, what can I do for my RDS events, for example? You cannot do it because it's just CloudTrail, right? However, we have SQS, which is like a messaging queue. And the cool thing about AWS is that, I'm not sure if you're familiar, so AWS has something that is called CloudWatch. So CloudWatch is their monitoring and eventing service. It allows you not only to monitor all your infrastructure within AWS, but it also allows you to send events from one service into some of the target. And one of the things that it allows you to do is that it basically allows you to create a pipe within any kind of AWS service that you're using to send it into SQS queue. So that way, if we plug our EDA to an SQS queue and we configure AWS to send all events to SQS, then we can potentially consume any kind of AWS service event with EDA. So this is actually CloudWatch Event Bridge. So yeah. So in Azure, so it's similar. So we have an Azure Service Bus, which is more akin to SNS. It's kind of, I think it's more of a PubSub system. Now the cool thing is very similar. Yeah, I would use the same pattern actually. So Azure has something that is called Event Grid, which is similar to CloudWatch Event Bridge. So it basically allows you to connect any Azure service to send their events into Azure Service Bus. And since we have an event source plugin that can connect to Azure Service Bus, we can consume the events and we can potentially just create rulebooks to react to any kind of Azure-related events. So in the case of GCP, we don't have event source plugin for GCP in 3. Unfortunately, there is some PR that has been lingering for some time. We haven't got reply from the author, and yeah, I don't think it's going to emerge eventually for the PubSub system. However, what can we do for GCP? Since we have the webhook event source plugin, that's kind of like the most versatile thing that we have. In GCP, you can actually have a cloud function. No, it's a Cloud Run. It's Cloud Run, which is their serverless offering. So you can create a Cloud Run function to send a webhook for some event that is happening in your GCP account to send it to a webhook. And that webhook is pointing to EDA, then you consume it with a webhook event source plugin. For Kubernetes, so we have two options. So there's a community plugin, event source plugin. It's called Saber 1041.eda. That allows you to basically define as part of the event source plugin what custom resource you want to subscribe to, and then you will get events from your cluster. So imagine that, hey, I want to get events for any config map event happening in my cluster, or any node event, or any deployment, whatever you can think of. Okay, so one of the issues that I see with that plugin is that it actually just limits you to listen to one particular event, and to me that's not super useful because you may want to basically listen to multiple kinds for multiple event types. And also because EDA unfortunately does not have a credential system as AWS has right now. So you have to provide, when you create the Ansible rulebook activation, the Kubernetes cluster token as a var, and it's not encrypted. So it's not super great. So what I actually prefer is to use something that is called KubeWatch. So KubeWatch is a tool that Bitnami created is a tool that you can run as a pod, as a deployment in your cluster. You configure with a YAML, okay, so these are the things that I want to get notified about. So I want to get notified config maps, nodes, deployment services, whatever you want to basically get events from, you specify as a YAML. And then you specify as a parameter a webhook URL. So whenever there's an event for the things that you are subscribing to into the cluster, it's going to send that as a webhook event, which we're going to have EDA behind. So yeah, so as you can see, so the difference here is that with the first one we are consuming, so we're polling, and with the second one we are receiving, we're listening. Each one has its pros and cons. Okay, so what time do we have? 5? Yeah, I'd rather just have questions. Yeah? Okay, yeah.
Okay.
Questions. Sorry, but
Questions, anyone?
yeah.
Yes.
Is there a way to do rate limiting for events so that you don't trigger an operation
Yes.
the second?
That's a very good question. So there's actually a way, as part of a rule, to have something, I think it's called once within. So to prevent like a thundering herd of events, you can actually, okay, so if there's been an event of this class, wait, just, give it time for the system for the next 5 minutes or 3 minutes or whatever, and then it's just going to basically ignore it. That's a good question.
Ricky, can you repeat the question?
Yeah, sorry. So he was asking if there was a way to put some sort of a rate limiting for the event matching, and the answer is yes. There's an attribute for the rules that I think it's called once within that allows you to specify some period in which you basically give Ansible rulebook some chance to basically cool down. If there are like a thundering herd of events, it will just process them each X minutes that you specify.
Is it possible to get the information from the inventory also from the event, or is the inventory still like the file or whatever?
Yeah, so actually, so what you do, so he was, the question was, is it possible to get information as a rulebook activation from the inventory, right?
More in a way that now the host that you run on is now based on the inventory, but is it possible to remove the inventory and get everything from the event?
Yeah, so if it's possible to shuffle inventory. So for that, I recommend, because it's actually tricky to do with Ansible-rulebook in plain and run playbook actions, to just leverage AWX. So basically you put the inventory into AWX hands, and you do the management of the inventory in the AWX, so you don't have to care about the EDA. So you would run a job template in AWX, and the job template has an inventory tied in. So you do that association on the AWX side.
You can also write your playbook that it starts with create a dynamic inventory with just the ID of the event.
Okay.
And then
Yeah.
in AWX we run it on local, but then in the same part,
Yeah.
call that inventory.
To be honest, run playbook, like, it's cool and everything to get going, but it's not super useful. The real power of EDA is when you couple it with WX, because then you get all of a sudden the benefits of inventory management and credentials management, which you do not have as of now with EDA. More question? Yeah.
But then, how do you integrate EDA with like AEP or AWS? I mean, where you create the rulebook, is it something that you create in AEP, or it's something that you have to create in a separate environment?
So so the question was how we integrate
a rulebook?
ADA rulebooks within AAP.
Yeah.
Okay, so good question. So in the AAP world, within the operator, you can install EDA. You just create a custom resource and it will install EDA. The same way you have automation controller, you can have EDA controller. Now, EDA has the concept of a project, which is the same concept of the automation controller and AWX project. It's a Git repository containing rollbooks in the case of EDA. How you tie them together is you create a token on AWX or an automation controller, and then you specify that in EDA. So then that's how EDA can call AAP automation controller or AWX. So that's pretty much how it works. David, I was waiting for you.
So earlier you mentioned how there's a new operator now, and that half answers my question from last year, which is great. My question from last year was, typically during EDA demos, we see the person running Ansible rulebook in the foreground.
Yeah.
But if you're going to be running that in any kind of production, it's not going to be running in the shell. Yeah. So my question back then was, how are you expected to run them? Is it like in a systemd unit or something like that, right? So is there a recommended way of running the rulebooks outside of operator and AAP?
Yeah, the recommended way, to be honest, is using EDA server, and since it's installed with the operator, that's it. Why? Because it provides you an API, and the API allows you to activate a rulebook. So that's like an on-demand thing. So when you import a project into EDA, it doesn't mean that, all my rulebooks from the project, all of a sudden, they're running. You have to specifically go and say, hey, I want to activate this specific rulebook within the project. And that is something that, you can just do with the API, so it's better with programmatically and whatnot.
So the context of my question was basically, maybe I don't have a Kubernetes environment to deploy that in, right?
Yeah. So then you would need to take care of the dance of syncing the project with the rulebooks. And as you said, I have done it. I have some other colleagues that they have done it, that we run internally Ansible rulebook as systemd scripts. But then you are on the hook of managing that syncing, dance and whatnot. Oh, yeah, sorry. Yeah, I'm sorry. I tried to cram too much information. I really wanted to do the demo. I didn't do it. Anyway, so this is like, my Arcarilla Cruz. That's my GitHub handle, Cfgmgmtcamp 2024. That contains the demos that I was hoping to do. It contains instructions. Cool thing, to install EDA in Minikube. So hey, no. So you don't have to say, yet another, Red Hat, corporate thingy. No, it's upstream. You can go Minikube, you can install it, and you can use it. So yeah, and it has, a couple of rulebooks that shows you, how you can work it with webhooks and whatnot, and some other event source plugins. And if you have any questions, please send me LinkedIn, connect with me. I'm more than happy to connect with people. Okay? Thank you. Well,
The mic is only for the recording.
Our next
The room is
talk
not big enough to need.
Internal databases operations at OPS Cloud with Ansible.
Okay, just put that in there.
So new databases can be tested every day, but how to deal with the vulnerabilities, like patch the vulnerabilities and the schema migration. And so now our next speaker, Julian, is going to take us in that journey of how to do that easily and simply. So Julian, the stage is yours.
Thank you. Hi everyone, I'm glad to be here. Today we'll be presenting you how we automate things to manage internal databases at OVH Cloud using Ansible. My name is Julian and I'm an open source DBA. So my main role is not an automation engineer or something like this. I manage databases. So this is the first time for me. I'm talking at a general conference, so please be kind. And you can find me, find my website, and I'm also active on Mastodon. So today we are going to talk about who are we, what infrastructure we're managing, with which management tools, and of course we are going to deep dive into Ansible codebase, giving real-world examples, and more about the implementation of Ansible, how we use it, and also a quick introduction of the development part of Playbooks and what's next. So who are we? We are OVH Cloud. How many of you know OVH Cloud here? Oh, pretty much a lot. So we are a major cloud provider in Europe. We have data centers worldwide, and we provide a lot of cloud services like bare metal, public and private cloud, and even managed services. But they all have one thing in common, which is they all the product we have rely on internal databases at some point. So the thing here, we don't have place for downtime, because every downtime we have generates error to the customers, but not directly on their service, but on what controls their service. So what's the managed infrastructure? What we have to manage on a daily basis? We have 3 database management systems, which is mainly MySQL and Postgres, 50-50, and some MongoDB. They are spread around across 7 autonomous infrastructure. There is not a single one, because we are worldwide, representing 500 and more servers with 2,000 databases, and they are divided in hundreds of clusters. And the most important part here, they all run in a highly secure environment. We are audited every year to have the PCI DSS compliance. So what's a cluster? A database cluster here, as I said, we don't have place for downtime, so they are highly available. We have load balancer on the top. We have mainly 2 nodes in semi-synchronous replication. So if we lose one, the other one automatically take over. And we have another replica, an asynchronous replica, that we use to perform backups based on file system snapshots using ZFS. And the traffic doesn't go to the backup. It's totally isolated, so there is no impact for the service. And they all have SSH, which is important for the talk. Database we host are mutualized. That means the database we give to the developers are on a shared infrastructure. One database from one service can share the same resources as another database on other services. And they all are on clusters. You can see there are 2 clusters here with multiple databases. So what tools do we have? We manage the infrastructure with Terraform. So we create, replace, destroy servers. We scale up and down. And we use standard providers first. We use vSphere, PHP IPAM, AWS for the buckets, for S3 compatible buckets, and OVH, because there are some parts that rely on their own products. And we also use Puppet, and we don't do everything with Ansible. Puppet here is mainly used for configuration management. We push configuration to apply security on the operating systems and install packages. And from time to time we apply the Puppet agent manually, because we need to check every single changes, because an automatic agent could be a real problem on some case. So we have such control on the infrastructure. And for the rest, we use Ansible. It's mainly for one-shot operations, like creating databases and stuff. Coming from the users, so some new projects comes in, we need 1, 2, or 10 databases. We can't predict it before, so they come from the user, they require us to create new databases. We also perform maintenances. And we act on external resources, like an orchestration tool. Some operation examples. At the end of the cluster installation, we need to sometimes to tell which node is the primary and which is the replica and bootstrap some things. We can move, create, delete databases, as I said, users, permissions, and stuff. We can perform schema migrations, major updates, minor upgrades. Sometimes we need to reboot servers to boot on a new secure and up-to-date kernel, for example. And we also decrypt the disks, because everything is encrypted as much as possible. And perform daily restores on particular environment. So these are the types of operation we all do with Ansible. And of course, sometimes a reminder is great. Automation is really important. It allows us to reduce human errors, free human time and energy, which is really important, because at OVH Cloud we don't have the time, so time is money. And focus on what's important. As I said, I'm a DBA, so I don't want to do something else than DBA stuff. So let's deep dive in Ansible. Our code base looks like this. I know this is not the best practices, but it works for us. All playbooks are a list of plays that all include one or more tasks. So we have tasks, not roles. And tasks are all under the task directory. There are a lot of files, but we have a naming convention with the scope and action. And tasks are designed to be reusable. So if we have a very specific unit of task, we can call it from multiple playbooks. And of course, we design our playbooks to be idempotent, so we can run them without asking us, hey, does it has been already executed before or not? No, we just run it. Real world example. Schema migration. Applications evolve all the time. We have new needs, and it implies to update the database schema. All databases schema internally are reviewed and applied by DBAs. This is really important for us. We don't want to release something that hurts the database. It can be a bottleneck. That's why we're automating the application. We use SQL Migrate because we have multiple databases, database DBMS. It's compatible with MySQL and Postgres. That's why we use this tool. And we have up migration. Here we create two tables, very simple, and the down migration. The up is to move forward, and the down is to roll back. Because just in case, if something is wrong, we roll back. The important part here, we don't manage the data here, only the schema. So if there is a destructive action, like drop column we just created, all the data that was in the column will be destroyed. So very important to know. And we can create playbook like this. First, we need to check arguments to fail early. We don't want to fail at the very end because the playbook can take time to run. We update the database, and we have the playbook on another play grouping tasks, because all the tasks will be run on the same host, and we have hosts that target a database name and a subrole. More on that later. For the task, we just call modules. Each section here is a file that can be reused. We tend to have a single file. Sometimes it requires us to have multiple modules that being called. So we create the directories. If they are not already here, we just ensure they are created. We create the configuration for the database, because databases are dynamic. We don't know which database there are in the first place. Then we clone the schema, because the migration are all on Git. Then we run the migration here with a command. Database creation. We just create a database, right? Easy? Well, this is not as simple as that. We just check arguments like every playbooks. We select an available cluster because we have hundreds of them. We create a Git repository because databases can share the same schema or have a new one, so we have to handle that. We run create database using the right module. We also create secrets. We have an internal implementation to store secrets. And we create roles and users based on those secrets for applications and also for humans, because developers like to debug on productions. And we link the database to the Git repository, and we run schema migration using the playbook or another version of the playbook as I shown before. Something very important is the minor upgrades. We all want to have an up-to-date system to fix security issues or fix bugs. It happens. Even on major version, there are several bugs that need to be patched. And for that, we use Ansible to orchestrate the upgrades. Like we upgrade packages, the DBMS and the system. We eventually reboot the server if needed. And the high availability system does the rest for us. So we just reboot the server, don't care. And we restart the DBMS if needed, because if we pull the new binaries, we have to start on the new binaries to be effective. And we order the steps by criticity. So we all check the argument. We start with backup host, do all the things, replica, primary, one by one. And if the playbook fails at any step, it stops. Security. And we have an alert. We can see what's going on. And we end with the replica and primary load balancers. So at the end, everything is up to date. We can move databases because sometimes a cluster can reach the maximum capacity, or we just had created a bunch of databases and they are not grouped logically. For example, one product needs all those databases at the same place and another one spread across all the clusters. We will have to move around databases. We can also isolate noisy neighbors. If there is one big database that's doing all the noise, we would like to move others. And major upgrades are performed by moving databases. We just take DBMS, for example, Postgres 14, and another cluster in the latest version, and we move the database. Of course, this is not the only operation. We also test before, but it's one way to use it. For that, we use logical replication. And for the database world, it replicates all the changes between one database to another. And we have 3 playbooks. One to check if everything has been set up correctly, everything is okay, there is no error in the replication. We have a migration playbook that includes the check playbook, just in case we have forgotten to execute the check, and eventually the rollback playbook if the migration fails or we have detected an error afterwards. Using this method, we have moved one data center entirely last year, from an old data center to a new one that represents 400 databases, 16 terabytes of data with under 30 minutes of downtime accumulated. So there was a big focus on execution time of the playbooks because every second counts in such operation, and thanks to Ansible. So we use some external collections. We use the community, General, MySQL, MongoDB, and Postgres, to name a few, but more. And we also have internal collections that are not open source. For example, the first one is really specific to our own services, but the other one may be open source in the near future. To perform operation with MySQL using group replication, Patroni, which is high availability manager for Postgres. We have a wrapper over that, and SQL Migrate. So now, how we use Ansible? So where? Ansible is used mainly through SSH, but we don't allow direct connection to our servers. We have something called the Bastion, which is an SSH gateway. It's open source, you can use it. It's audited, it passes the PCI DSS recommendations, and it was designed to be used by humans. But we also can use with robots too. And it's available there. Don't worry, my slides are available on my personal website, so if you need to go afterward, you will have all the link you need. And we can plug Ansible with the Bastion with another plugin here called the Bastion Ansible wrapper, and we can configure it like this. It supports file transfers. My take is please use SFTP, not SCP. It's deprecated, so please use SFTP. And the inventory. Where do we find our databases or host managing the databases? We use Console, which is a distributed and highly available data store used for service discovery. There is a local agent on each server, and it's available here. So the basics of this is every agent send information to the console servers saying, hello, my name is Node, I'm part of the cluster and I have all those databases regularly, so it's a service discovery. There are nodes used to have names, IP addresses, so where we can connect to the host, and metadata. We can filter metadata. And we use services to declare databases. And it's secure with ACLs and tokens. And it uses encryption, which is great for secure environment. We have a bunch of static configuration, like information that never change, like server type for Postgres, MySQL, the filer we have for the backups and stuff. The role, which is a node, a load balancer, a backup. Here, there is a node, not a primary or replica node, because there is a sub-role. A node can become a primary or a replica and change over time. And a cluster identifier. So the sub-role can change. We have a dynamic configuration. We have an agent, a cron job locally that discovers all the databases and the sub-role and updates the information in the console. So where is my database? Oh, right here. The test database runs on 3 hosts, and we have the role, replica, primary, backup. So we can find our database. And we can use it with Ansible as a dynamic inventory. So how we can use the inventory? We can use with Ansible or Ansible playbook using the limit. So here the server type Postgres will target every PostgreSQL host. We can combine multiple groups with the intersection, with a combination of multiple group or exclusion, and it goes like this. If we want to run schema migration on the test database, which is and the primary, we can do it, and a lot of combination. Execution environments. So it's okay, but technically, where do we call Ansible? Where does it run? We have an admin server, which is a virtual machine, accessed by SSH and shared, but there is no API. You see the problem? In a very secure environment, shared environment is not an option. So we have this to configure AWX. AWX is an Ansible orchestrator or controller. We run it on Kubernetes. And we can plug it with the corporate system, like to use our personal account for more traceability. And there is a REST API, web interface, CLI. There also are notifications. So we want to know when a playbook and which playbook has been run. We use it for alerting. If a playbook fails and we want to have alerts on certain playbooks. We have a chat notification. We have a channel in our chat that sends all the what's going on with AWX. So basics of the concepts of AWX, there is an organization, projects, teams, users, privilege. It's pretty complete. We can plug inventories, multiple inventory sources, which is great. There is source control, so we can tell the AWX where the playbooks are. We can define credentials with our SSH keys. We define also job templates, which is the link between the playbooks and AWS. We also can schedule jobs. We have some jobs that run periodically to restore the databases. Some databases on some environment, we have periodic restores. We use AWS for it, and notifications. So what does it look like? For example, if we migrate a schema, we can go on the home page, then go to the templates, searching for the right template. You see here, database primary schema update. We can run it. Next, put some variables. So what database, which schema, what branch, if we want to test branch on the environments. Click next, and we have notification on the chat. We can also click on the UI to get for more details. And the job has finished. We can also use the CLI with appropriate credentials, of course, the personal tokens, not shared one. If we don't like UIs and click next, we can use the CLI in one line. And boom, we have the same. So AWS is great, but it can be hard to configure. So we have Ansible playbooks on a virtual machine to do this stuff using the AWS collection. But we also have a Terraform provider. So we can get rid of this virtual machine and use only Terraform. Of course, AWS runs on Kubernetes in our environment. There are multiple components, the web components for the UI, the REST API, and a task, which is like the controller of what's going on behind, and execution environments. For every playbook or every job, there is a pod schedule in Kubernetes. So for the next part, I would like to put a disclaimer. I will show you some errors that may be related to our internal implementation, not our external offer. So if you use AWS on our public Kubernetes, maybe you won't see those errors. But I find them great to show to you. We have quotas on Kubernetes. Don't be too restrictive with the quota, because you can have some serious issues like tons of errors or pod not scheduling, and can be a mess to debug. The important part here is you have two components that stay all time, which is the web and task component, and the execution environment are spawned proportionally to the jobs you have at a single point in time. And we have global quotas on the namespace, and the execution environment can easily reach this quota. We had a major issue, which is the job execution time. As you remember, we have moved a whole data center, and we would like to have seconds of execution time, not minutes or hours, seconds, as fast as we can. And here we can see that a job can have some dependencies, some hidden dependencies, like refreshing the source control, refreshing the inventory, scheduling jobs, pods, starting pods, and finally it can perform some work. But of course, so yeah, a simple ping, very simple basic ping, could take nearly 2 minutes. But there are solutions. We can cache some information, like using source control management cache and inventory cache. So if you want to be as fast as possible, you can trigger you can update those cache before running the migration, but you have to keep that in mind before. And you can check the quotas, and of course analyze the playbook itself. So yeah, okay, it's great. We can have fast playbooks. And for storing secrets, we have our own implementation of something like Vault. I will tell it's custom Vault, it's a homemade. It's designed to be managed by humans and not robots, which is an issue here when we want to automate things. We are not humans anymore. And it's designed to be cached. So what's the problem? Cache is fast, right? During this migration, we had 70 databases at once. The endpoints of the databases are embedded in the secrets. So it's a JSON with endpoint, user, password. So the application is able to read this information and to automatically connect to the database. And we have 4 secrets per application, per database. Every lookup to this service took 4 seconds. Yeah, 4 seconds. It's not that problematic, but yeah, 16 seconds per database. And if we do it sequentially, we have 18 minutes just to update the secrets. So it adds up, 20 minutes. That's half of the whole migration. This is not acceptable. So why? Why is that? The API for this service made for humans has different behaviors. We can search by name of the secret, because the database name is the name of the secret, but only by IDs. And in order to get the IDs, we have to issue a get all secrets. And by getting all secrets, this is the 4 seconds. And there is, to complex things, we have different behaviors depending on what authentication we have. For the application key, for robots, and basic code for humans. By default, it's designed like this. You have here the content of every secret in one call. Yeah, this is handy, but it's not performant because it takes 4 seconds. And every single time we have 4 seconds. Another one, using basic code, we have get secret, and we don't have the content anymore. We have just a list of the ID and the name. So we can use another endpoint which exists and to get the content. 2 calls in milliseconds. It is way better. So we ask to use this method to automate things to another team internally. We have created another lookup plugin because we didn't want to break the existing one, and we can use the one when we have to do. So there is, and every pod we create, we have an init container that automatically get all the secrets locally, so we can read the cache, and here is the cache. But sometimes when we create a database, for example, we don't know the secret beforehand, but we still read from the secret. So we need to bypass the cache. So while this is the second one. So it's okay. My general take here is don't reinvent the wheel. If you have something that handles secrets, please deploy standard services. Don't do the same. We also had some errors on starting pods. Pods without networks. A simple lookup here does timeout, then the job is broken, then all dependent job broken. Oh, we have a lot of errors. What happened? The solution we found is replace IP tables with NF tables, because IP tables didn't keep up with the network flows we are throwing at Kubernetes. So now the problem is solved. We have way less errors. So we have errors like this. We did have those errors every day, multiple times a day. So it was kind of annoying. Another thing is we use console federation, because as you can see, we have multiple environments here in France, here in Canada, and some others. And for easy configuration, we use a federation that provides a UI that we can switch data center to see, and we used it to define our inventories. Okay, there is only one moving part, which is the data center and not the URL, and we used it. But hey, that's not that great. Here is the job that updates the inventory, and as you can see, it failed a lot. So instead, please use local servers or services as much as you can. The problem by using this is we have to tell the configuration to use one host, one particular host of the cluster. So we kind of lose the high availability here. But it's a risk that we can take. If we don't have the inventory up to date, it can fail. Okay, we can rerun the job and it can work, or update the information, and we have only one error, not tons of error like we did. Or you can deploy an agent in Kubernetes. That's kind of a hack, but it works. We also had connection issues to the database, because AWX requires a database to run, and we operate databases. Sometimes we need to reboot servers or restart load balancers, and the database connection is cut. So what happens? AWX is lost. Just whoa, did you cut something under my feet? So we use HA proxy for the load balancer. The first solution was to persist the state at every reload, and every restart will read the state. And the script is here, just simple bash script to save the state. And the second one was to use keep alive. So you can, in your credentials.py in AWX configuration, you can specify keep alive, enable it, idle, interval, and count. And with this configuration, if you slightly cut the connection to the database, AWX is able to recover. A little bit about security. We watch security CVEs on a regular basis, like every week here. And we use base Docker images available on Quay.io. And we can see here that we are not on the latest version of AWX, but we have some CVEs. We use JFrog X-Ray, which is a proprietary software, but we can have the same information on Quay.io, which is great. So how can we reduce the number of CVEs? We can use the community MyNumber images. They are available on GitHub, and we cut the number of CVEs like there is no more critical CVEs, which is okay. And now I would like to show you how we develop. There is no fancy IDE or something like this. Sorry. We use an admin server on a lab environment, which has all the hosts. It's basically the same as production without the risk of the production. It's totally different. There is no data between pipeline between both environments. It's totally isolated. We clone the code base. We did some files, run playbooks, and create patch, like the old days. And it works. It's not great. It's not shiny, but it works. Okay. You have run your playbook. Okay, I trust you, but verify. The fun fact is, it's not Wilfried Rose here, the author, but he's my manager, and hello if you see me. He he uses this program every time, so thank you for that. We use Ansible molecule for test. It allows us to run a scenario sequence. It's designed for playbooks and roles, but we use it for tasks and playbooks. Basically, we test only the syntax, because not everyone is perfect. At least it's something. So it goes like this. We have a directory called molecule and ping for a ping playbook. We have the molecule.yaml and converge, where we define the scenario and run the playbook, and call the playbook. So we use Docker, and with a Debian image, with a sequence of lint and syntax, and it does the job. And converge to import the playbook. Very basic, but at least it does the basic stuff, and it's okay-ish. And for that, we use a CI/CD product, which is developed internally, but it's open source and it's active, so you can check this out. It's called CDS. The workflow is here. Every time we git push a branch, it can run hooks on CDS. Pretty much the same as you send to GitHub and does the CI/CD thing. We use Bitbucket because it's the source management system that has been chosen for the company. And it looks like this. There is a UI with a simple pipeline. If we click here on the pipeline, we can see all the steps, and we can see the different builds. And we have 113 playbooks, so we have 113 tests, and they all pass. So okay, not often the case, but at least here they pass. So what's next? We would like to use event-driven Ansible, because the schema migration, for example, we are able to detect the merge operation on Bitbucket and to automatically apply those changes on the infrastructure. We use a custom software today, and we have test event-driven Ansible, and we have even patch event-driven Ansible. So if there is maintainers here, please make a release. It's been on October last year. We have some changes we would like to use in production for Kafka authentication and AWS authentication using basic auth, for example. We would like to improve molecule test, of course, because syntax checks is not enough. And we would like to schedule unintended minor upgrades. So every 3 months, for example, or every week, we would like to have automatic job using scheduled job and playbooks. We have all the things, but we just need to be confident with them. And last but not least, okay, it's great, you use Ansible, you do a lot of stuff, but Kubernetes can do that for you. Yes, but we are not confident enough, especially with all the Kubernetes implementation we have internally, to put the databases right into Kubernetes. We are far more confident into Ansible and AWS than Kubernetes itself. So that's okay for me. Thank you for being here. It was a great pleasure to attend this conference as a first-timer. Thank you, and if you have questions, I will be happy to answer.
Thank you, great presentation. I have many questions. I will just ask one. So a lot of the focus you said was on performance, and you have data centers all around the world. So I was curious how geographically distributed was the bastion and the AWS environment. So are you running, for example, AWS in a single location and then reaching out to all the other data centers? Or do you have like multiple clusters? How, if you go into that?
Yeah, so the question is we have worldwide infrastructure, how we manage this geo replication or the geographic implementation between them. They are autonomous. So we have one AWS in each region, which is each environment, we call that like this, and there is no communication between environments. They are all databases, all control plane at a single point, and we deploy it on multiple points. There is no communication between them. Yeah.
Thank you.
Yeah.
So you manage the states using console. You can retrieve the deployed databases. So where do you store the state, the users, permissions, and everything? Is also in the metadata of the console?
So the question is we use console to persist the states of the infrastructure or the databases, and do we need to store? Do we use console to store the permission and the users? The answer is no. We provide permissions, 3 sets of permission per database, which is read-only, read-write, and admin for select statement, DML, insert, update, and delete, and DDL, alter, create, drop. Generally, the default privilege is read-write. So when we create a database, we assign read-write role to an application user, and that's it. So it's already predicted when we started. We don't discover them afterward, and also we don't create personal users on database. We use a feature on the Bastion that can plug all the permission for humans and connect using the appropriate user on the database. So we delegate the permission on the Bastion. So everything is on the Bastion. Yeah?
Thanks for the quote. If you were to start this from scratch today, how much of this existing tooling and capabilities would you keep?
Everything. Because it works, just works. We don't want to reinvent what we have done. It works. We want to move on. Yeah. But if you want to start a new thing, use something you are comfortable with. You can do some research on your own and test infrastructure and gain confidence and experience. It's necessary to go through all these steps. But putting something on production that you don't know is a big risk. So just use what you know or you're comfortable or confident with. Yeah. But it's a way that works. So if you want, you can. Yeah.
Continuing on his question, what do you think about clustering, for example, Postgres within Kubernetes, or Kubernetes that you tightly control with all the versions and all the upgrades and all that stuff, with your operator, which is the hype thing that many people are trying to do, or why you think it's a bad idea?
No, the question is what's my do I want to use, or can I recommend to use Kubernetes operators for managing databases? My answer is the operators in the database world are created by DBAs. I know them personally, so I have confidence in them. There are quite high quality operators out there. The issue I have maybe related with our own experience of Kubernetes, especially on the persistent layer. If you have to persist data, like using PVC or something, and because, for example, Postgres, or you can create new server and clone the data between servers, but what happens if everything is lost and you don't have persistent storage? You're done. You can restore from backups and things. So you have to use persistent storage, and I have no experience with them. So, but the operators themselves are pretty high quality. Yeah.
So you would say if you have kind of SAN storage as external, if you fully automatically deploy your Kubernetes and can redo it in a disaster recovery, you would have nothing against using operators to operate in the DBs on a persistent storage that's basically just mounted inside of Kubernetes.
The question is if I have something that can persist data, would I be confident to use the operators and put them in Kubernetes? Yes. If they work, yes. Why not?
Okay. Thank you so much. Thank you so much, Julia.
You're welcome.
Now we are going to break for now 10 minutes. Now 15 minutes over. Please go downstairs and get your walkers.
Thanks for your talk. Are your slides available somewhere?
Yeah, julian.ryu.xyz.
It's only for the camera, not for the room. Still enough in there.
Okay, great. So you're
Hello, test.
Yeah.
Check. Hi, hi, hi. Do you see me? Do you hear me? Perfect.
You tap on the mic one. Yeah. 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 You move lever one of you to the right.
Cool.
So. Let's see. You have a demo or anything, or just
No, just
okay. I'm moving slides. Just take. I'll just leave it focus on you guys. Okay. Good luck.
Yeah. Today I said. I think it's artificial. Yeah.
No, that's my idiots.
You can do a lot.
That's my direction. Legally.
Es gab einen Bock bei Public für Fall. Und haben sie manche nicht weiter verfolgt.
Aber, ja, deswegen bin ich gespannt, weil man kann vielleicht schon weg, dann ich mir keine Question programmieren muss und dann hier.
Muss immer noch.
Ja, jetzt nicht alles wie ich gemacht habe. Ja, das ist sogar eine richtige HTML-API.
XML.
Es gibt auch unterschiedliche API.
Mit Thema. Ja, aber
mit
nach Dokumentation, die
Das ist das Problem, wir halt auch ein Partner.
Das würde ich dann mir anschauen wollen und dann kann man API einreichen, die Ordnung mit dem Code auszugehen.
Ja.
Also es gibt eine das PDF, ich glaube nicht, dass das Format ist.
Also es muss schon mindestens
Ja, das ist auch
Nein.
Willst du anders machen? Du musst ja
Nein, aber anders dringend.
Du kannst da nicht dann. Also ich bei der PDF mit B.1.017 und das String packen.
Dann doch lieber
Aber das hilft nicht.
Ja. Do it.
Ist das
Das war's auch.
Chips or the name? I think. Because
I think that's
you asked me a question, how should be introduced?
How would you like to be introduced?
Okay, no advice.
Thank you, Don. Hi, and welcome to the talk called Generating Ansible Modules for REST APIs without AI, and it was great enough that you showed up here and got built interesting. This is Matthias.
Yep.
Introduce yourself.
I'm Matthias. I'm senior software engineer at Red Hat. I mainly work on the POP project, and for those of you who know POP, it's a service API. And since I've worked with it before, but the story, I got with the idea to write POP Screener, which contains currently about 30 modules.
Yesterday.
All talking to an API, to one API. And I actually see a certain pattern here.
Yeah, because I'm also here at Red Hat. I'm not working on POP of this world, but my main project I'm working on is Foreman, and Foreman has one API, and we have like 8 years of main modules for that API, and we have now 8 of them, and as mentioned, they're all into one API, well, different answers, but same thing, and we kind of thought that we need to make our life easier. Because like writing Ansible modules is kind of this job, and it's very repetitive to do it 80 times, and we are in no way like fishing between what the API provides and our both positions. So we can go on and write new modules daily probably. And that was great repeating. Like the thing we often see in those modules is have a set of common parameters because you need indication, right? You need endpoint like the base URL of the API you're talking to. They're all the same, and you do not want to have to write them again and again and again. So here we are, and going to do it with ChatGPT. No, we aren't, but we tried. Okay. We tried, and they asked it like how to generate a module for working with, I think it was Foreman, using that as an example for some now. And it no gist, right? But module didn't fully work, it's very inefficient. And what it also didn't do, it did use any abstraction that would actually be available, right? It would use plain pin requests, it would hardcode all the URLs internally in the module. Because ChatGPT does, like, it can scan the internet, right? But it cannot know how to optimize things. And we are no prompt engineers, we are YAML engineers, Cfgmgmtcamp, right? So we might just like use it only, but in the end, I could use CRL and just use module.run and then CURL instead of using requests. I have no idea how I made do it. So yeah. It was more used than actually helping us. And even if it like generated a module, it was in the module, it has no tests, no documentation, no examples, nothing. And that's something that we want.
And we may say when we expect such a model, we have something like the webhook, and we want it to be a nice Ansible plugin, Ansible module.
Yeah, also plugin. Computer terms. Yeah.
Yeah, and that has a state and look up first, and then delete or update or create, depending on what is needed actually.
But also failed to actually understand the API, so it didn't do pagination, so it would only get like 10 results. So if you have 11 webhooks, it would have tried to create the 11s over and over again. Again, probably you can teach it to, and then like the next obvious thing was like, Ansible has for that with AI, and I see Ricky in the room right now, because he was like the first person who ever talked to me about like, Ansible and AI. It was still called Wisdom back then, and up to this day, it can generate modules, it only does tables. So it's no help whatsoever. I have no idea if it will ever do that for us.
Maybe helpful.
It might be helpful, yes, but today it can't. And this brought us to, okay, the common AI tools don't help, we need to go back and use a computer like computers supposed to be used.
Yeah, but still we already had experience with writing some of these plugins, and they were really very similar. And so next idea is it possible that we can write a single template to just get all from the same DNA, so to say?
No.
And yeah, there's a Python project out there named Cookie Cutter, which is kind of nice. You can write a template, and when you run it, you provide it with a couple of answers, and then it does something for you. On the inner parts, it uses Ginger, so that's also very familiar when you're already in the ecosystem. But yeah, specifically, Cookie Cutter is for parts creating a new file system structure, and it always takes a directory. So adding a simple module or a simple module to your collection, single module to your collection, which is a single file, just didn't really work out here conceptually.
But also, it was like, hey, I can run Cookie Cutter and like ignoring the project versus file problem, and it will ask me questions, but like what to do, it's rather limited. Or I do write like a whole thing in the template that Cookie Cutter then uses. It was sort of like not what we wanted to do. Then we want to reduce work. Yeah, we want to reduce work, exactly. So I thought like, yeah, maybe we're having like the wrong input, and we should not write a string to an AI or try to make Cookie Cutter better. But what else do we have? And what else is documentation? Because most projects, hopefully today, when they provide an API, have a documentation that is machine readable. And we say, yeah, cool, let's try and do this, use this. So yeah. A common tool that to generate API documentation is Swagger, or so it's Open API now. Foreman uses API Py, which is a different tool, but the idea is still the same. You have a project that defines an API, and it can describe the API in a way that machine readable afterwards.
And it may include docs.
It may include something and everything. But what it will definitely include is what parameters do we need to pass? Are those parameters required? What is it like an integer? It's super important when you want to pass things. And this is nothing that we could have easily had without that. So, very abbreviated example from Open API. Thank you. That's such an easy name. Against the web hosting from Foreman, because the library that we're using, API, it uses a different. It's a library that uses a different format generally, but it can also generate. You can generate documentation from the documentation. It's right. But it has all the important things, like what you have to do, what's like the summary of it, but also like all the types and things. It's abbreviated, it's even more in there. I think it's what helps, right?
Natively only supplies you with OpenAPI 3.
Because that's DRF.
And the thing is done with that's
the side, and as a user, you don't really have care about it, but you care that there is a doc that is readable. Again, if you show the same thing on the API thing, API side, it's still different. It's different formatted, different structured. You have matter. Brought me some. You matter. What? We have nothing. Okay. But again, it doesn't matter what the computer has to pass, and it's super important. They get up to from writing weird prompts or trying to add a thing in the Cookie Cutter to pretty readable actually. Which checks essentially everything, right?
This is an example from maybe PyPy?
Yeah.
Basically.
Don't ask me about examples. This
is an Python library that knows how to read that API and just be able to do something and look up the details in the docs and create the HTTP request accordingly.
And you not only need to like write the data, send the payload to the server, and everybody will be hopefully happy. Right?
Or you want to provide programs.
Which is what I do all the time. Yeah. So this gets us quite nicely to a library that can talk about API, and maybe that now is every single entity about API, because we don't want to have a flat proxy for smart proxy for whatever, like IAM distribution. It gets us to templates, because we need to repeat something, and what's asking repeating is that's all things. You seem happy. Yeah.
That's basically the same node.
Yeah, same node. And as long as you don't try to templates, but that gets hairy at some point.
Yeah, it's we made programming won't use.
Yeah, I've seen that. I don't want to remember it anymore. Yeah.
Yeah, so we can use the docs downloaded from the server and then just loop all them.
And we're sending,
put them in a tag, and then we get a lot of modules.
Yeah, I'm sending you Ansible using Python Jinja, and tomorrow we will be in the Go room. We'll use something else, but it's still the same thing. Different language, still the same. I wanted to say something.
Yeah.
Okay. So this gets us from we need to write code manually or we should be able to write template and fit in. So what can we actually fill in? What's still missing in that?
Yeah. So now with the template, we can use the modules in Python that we already provided. We can well, the documentation is not the thing that we want for, and the module is not the API spec, so that still see color.
at least get us the structure of the
documentation. We get all the parameters.
We
We
get
can compile those part of the documentation. Right.
What you don't get is the example, but also the documentation was pretty sparse. Like you have parameters, you have the names, don't have good descriptions what they are about. But let's start. And it's a pretty good start. But still requires modification by the like still it's good.
So what examples? The examples are basically in the past. The documentation cannot open those. We want to write tests. That's always a creative.
Yeah. Well, tests and examples are pretty good.
Yeah. Right. And for some things, because no API is perfect, you need some logic. That can be anything from the parameter has a different name when you create or your object to it's not properly documented. It's actually required documentation, doesn't tell you all these steps you need to add later.
Or the more complex, not required thing is parameters that are required for creating and not required afterwards. Like you need to create a user that it has name and email address. The name is required for looking it up afterwards. You always have a path, but the email address will stay in the database. So
you can basically expect that you get a template and you get a module and then go over it and comment or correct it.
Most of script, please, and my experience.
And now things evolve, you get better ideas, and you want your modules to be structured differently. So you change the template, but have no to reply the template. Well, this needs sort of human interaction. Usually you get this, and then you can sort of this chunk was changed from the template, and this is the one like you can pass logic and all that.
So yeah, we try to make it written like things like 50 lines of Python code and a template and terribly called Ansible. Sorry, please naming. It's in the API JSON that Foreman provides, consumes it, and to like where it gets the JSON from and which resource you want to do a module for, it will get a module that is in many cases working. We do one module that's like updating resource, but it comes to info modules because we have base classes for those in our function. This was one thing that was making it super easy because the module really only contains from Ansible collections from import our wrapper and use that wrapper. We have handful of wrappers in the collection because on one hand it's evolved, but also need to talk slightly different depending on again. And it's a couple of those, but again, there's something that needs to be executed by a human and needs to be you think while doing so you can get base class pretty easily. And can you make it extended, like no problem. I can't get you any examples of unit test because this data is just not provided by the API though. It's a start, and I've used it to generate some models and also compare modules written by somebody to what has more done for me, and it's pretty close. It's good. And by working this, I also realized that it's actually already like done in the Ansible world. There is Ansible configurator in the Ansible commission it's a thing, and it's used to generate collections for AWS in there. I'm not sure what their like super sources right now. Maybe you know that. Tell us, please.
It's being retired once we get place for it.
For what? And what? And what will be replacement?
Will probably be functions in the Ansible Creator command line will be introduced.
Okay.
It's on the future board.
Okay, we got to talk.
Yeah, that's here too.
Because Ansible creators get not heard yet about.
It's really new.
Okay.
Yeah. It's new.
But it's also like approach by paying API doc and from there.
That's the plan.
Okay, cool.
Yeah, but I don't want to.
Just.
No, it's just. The way I was looking at it, and he said we don't see a path forward into this product. But like really does.
Good.
So we're going to looking at rewriting making a function of the Ansible Creator tool,
cool.
which is still very under instruction. So it's not going to need it. It's
Fair.
very much computer for this.
Awesome.
Okay, that's it. I'll stop there.
That's fair. Cool. Because that's gets us quickly to further because we have form and we build WS vendor. It's working, right? But it feels weird that we also so see it all of them because there's so many guys out there everybody needs to know. I think Contour already does more than those two, but Vendor and AWS are the ones that are using the OpenAPI and the mode it's like a cloud thing that you're talking to. It also can generate things like send it in NOR files. So more suitable for a whole collection generation than what I've it, but also people spend special time on it. But what you want to get to is like want to use it for everything, which apparently is and still as a creator.
Yeah. Yes.
Perfect. Yeah, you want to make this generic or people want to use it in JRA. So far, the way what I've seen in the content but also what we did is it cannot really make generic without really providing a template that is specific for that API. Want to try?
Sure.
They do?
You see, we already have API, we have API 2 Swagger, we have API 3. So, and at the end, all these API have some specialities where they kind of non-standard a little bit, and so you probably want a specific module abstraction for different services. And that just can be templated nicely, I believe.
Yeah. I tried in Contour like to extend it a bit to teach it more than Julius 2, and while the code would technically support it, I found it complicated to get my brain into it. And in my own, it was just very quicker, even if not the nicest thing to commit.
Yeah, and to be honest, calling Ginger really
it's really simple
pipelines
gets you way faster. It's pretty good. Yeah, one thing that Contour does that
our solution or shoot me next time I'm trying something, please. The other thing, yes. I poop. Yeah. You want things maintainable, and Ansible actually knows how to regenerate a collection because not all things are specific to, like, you have AWS, but then there are specific different modules, and it can regenerate and improve that. And we want to have more for everybody.
So you're saying the content builder is compiling the whole collection?
Yeah, it's compiling.
And the result you take, and our approach is we
generate
a new module that will be maintained manually.
We'll just click next slide. We'll have made such so yeah, if you just take a template and generate it over and over again, it would override changes that you see. And to be honest, that's like all in this way. You can make either always exist changes that you generate, or you need somehow to maintain your diff. And
yeah, and you should try to keep close to the template, so that the template doesn't change. You're not completely confused when you apply that and see what you need to adjust in your plan.
Or you put all log into template, which also has against point.
It's gotta be complexity needs to go somewhere.
Yeah, it's somewhere. It was Florence lock yesterday, and it always goes up. Just you can do. Yeah. And you can teach the code to algorithms, that's what I was saying. Like, content will do that, and what you have in the tool will fix it, or make it better, probably. Yeah, what you want, no, so then allows you like consistent code, it can be fixed and maintained. That's like, for form, we're doing this right here now. I think user is slightly younger, but also not that much, so, yeah. And Ansible is just saying yes. And
will.
Yeah.
So there are some things we did earlier, before implementing. For example, when you did Ansible, you don't want to execute them or itemize them more. So, small consistent calculations you can do rather easily set, and even better when all these are kind of similar, and that's one of the goals, to keep them similar. And the other funny thing I found in a Git history is actually something put in a makefile, so we kind of compile our models. Prior to Ansible 2.8, the collections, what was it?
The 9th one was collection support.
Yeah, and suddenly everything you have to qualify by name, or collection name and name will qualify name. But the repository itself was actually to be used the checkout, or the checkout. And so we still wanted to build a version, and for uploading to Collective, we ran this through the make file, which just add all the extra bits on the qualified domain names.
Again, you can only do this if your code is consistent enough and like structure strictly identical so that you can add.
But you want consistency anyway, it's good health. When you have more than 12 files, so to say, and they all look very, very different, then doesn't maintain them anymore.
Which brings us like to, I think, it's like kind of aside, and we like way out of time discussions around the utils. Yeah, you always need to start somewhere, and you always end up having at least one of these problems if you can because you need to figure out like, how structures think. So it's probably also the model that you all are doing this, but like, after research, maybe.
Yeah, you start to see patterns, and when you see patterns, then you can start to template things out. Or we can do the module that actually free up here. Obviously, you can just, when you do template, you can just put all the HTTP handling in a model. But it's good, you could. But yeah, we actually started with using module the first time they were available to us, and it helped a lot to get a cycle model down.
They also then create abstract frameworks, and abstractions aren't always good. It's not magical. It still feel magical to me after 8 years. But they're useful and allows you to have the module concentrate on the details of the things the module should do, and not like the common HTTP and authentication and everything. Just ignore it. It's a good idea. Yeah, and very, very, very useful once it supports module utils and documentation format for everything. For the end of collections. And like this, but it was also available, I think, 7 or 8, you could have this in a library style checkout, which was also already pretty good.
Yeah. And my observation in general is when you work something that is repetitive like a guy, where all different endpoints create update, root, and all that, and you go and try to not repeat yourself much, you basically always create a framework. So, whenever you do expect people to understand that you need to teach them what this framework to use. I don't think I have a single contribution about how they get it over the finish line.
What? No, I'm not exactly sure what you're going at.
You don't want we need to teach them how to read.
Okay.
The tests.
Yeah, of course. That's true.
Yeah, and the whole magic. So you could tell the folks, yeah, don't do that. It's already for you.
So yeah, that was it. Thanks for hearing us. Please tell us that you will generate all the modules with next one, which will be better. I hope this. I try to think that both one favorite and also the counter is yes, right, but difficult. Yes.
So since you're generating the models for the API manifest, as the model generation API, sometimes I think it's pretty useful if the module contains some ability to handle some, as a for example, with the satellite or modules, if you want to promote something, it's already in specific environments. There's some logic that's could be set inside the module. If it's not there at the moment, and you come to preview, it's very ugly.
Yeah, and this was the line of custom logic. You need to find a trade-off between I'm just taking literally what the API tells me. And like at times this is perfectly sufficient for taking the example, create a link or create a bookmark. It's a simple database, you just fill out the form again. The moment you get to more workflow things and content users more about that, you end up having logic and you cannot generate it from the API book, but you have a starting point. Because having a module that doesn't have this logic, but at least can the content use, or even having nothing. And then you can, as human, focus on the logic to make it better for the users.
I would add, first, there are that you lose something, and so I would not go for take API, compile the modules, and ship without looking at them. So at least look at was one manual step here. And for the workflowy things, it's again judgment call. I believe the modules should be very basic building blocks. They already contain, in our cases, the logic of first look if it's there, then create it only if needed. That's already in the modules, that's not in the API. And yeah, right, the workflowy things maybe can be better suited in roles, which is the Ansible level of abstraction here.
You had something, Felix?
One question. Did you look at this thing Google was using for the Google Cloud Collection? I'm not sure that still exists. Actually, it's Ansible. I think it also exists at some point.
I have no idea. Yeah, so the question was whether we looked at whatever Google did, and we didn't. I looked once at another compiler and run away swimmingly. I have no idea whether this works. What I've seen once, and it's also very interesting, is a collection for Ansible that would internally take Terraform, to Terraform and expose that's an Ansible API. It's horrible. So I propose not writing Ansible code, that's one.
The thing Google originally used actually create modules for different content management systems. So that has even more meta.
More okay,
I think they was called Ansible, and the collection kind of was dying. Now I can remove it, so I haven't really followed through it now. But originally it was written and moved, so wouldn't mind.
Yes.
I wonder what are your thoughts about pushing the abstraction as high as it goes. So by that we have modules, then we have some kind of modules. I think from as I did include, but I can client library, some kind of stuff there. Would you help using the duplication and the research template?
I think I can answer that. So module is already a library collection, and you can move all the Python parts there, and it. And so the typical module, you have an example?
Yes,
I believe you have. It's rather short.
Figure out. Yeah, it was already full screen. That's not cool. So. I'm sorry, I'll put it on my other screen and move it back.
So, like you shortly had as the Ansible module plus Ansible, and in module we have subclass of that. And given that they already know how to talk to command, only thing left is now to tell them what parameters we have and what parameters the module should support. And then basically the rest for normal the behavior API endpoints is much done already.
So modules. Can we get what was the easy book in this here?
Yeah.
So I have like boilerplate, then you have the documentation, which is mostly describing the module specific thing, everything else is documentation of remnants, and then examples and return, and the module itself is like this short, because you only need to specify all the parameters, and this is something you can get away with, that's how I thought. And you need to pass things like require for and then it's just call an API with having, or it has some logic here also, like very short. This is actually what the end generates. Everything is already module details and should stay there. What you cannot do is, but this is Ansible design, we cannot take the AI block live and put it down and at that point document recognition parentheses because Ansible uses like need to have this before it can run module.
Yeah, it's a module.
Yeah, exactly. This is a module. So that's how the API can work. It also uses API doc, but when you add in, it would first fetch the current API to visual server, and then validate parameters against that. So define it as best as possible in the module. And more. Good. And thank you. So that was your cable number 1. So cable number 2.
And the microphone is supposedly more back.
links in the slides, and I will also upload the slides after this talk. So every feedback is welcome. Just let me know what you think. I'm thrilled to hear what you think about this. Maybe let's start with a very basic example. Let's say you want to install SUSE Manager in under 10 minutes. All you need for this is this Ansible code. So what this does is, basically you see we have an assignment which host we want to run that code against, which is a SUSE Manager system here. Of course, we need root privileges to do so, and we also specify the Ansible role we want to assign to this host, which is the server role. And as we are installing the enterprise version of Uyuni, of course, we need to enter our customer email address and the registration code we get after buying the subscription. So all you need to do is enter those information and run the playbook. And it takes something around 6 or 7 minutes, and after that you will have the most recent version of SUSE Manager that is supported installed on your system. Of course, this also works with the open source variant. So let's say you want to go for a specific Uyuni version. We have the same role, but you see we do not have any email addresses or registration codes here. We have a version pinning to the Uyuni release 2023.12, for example. And you can also assign client or child channels you want to mirror after the installation. So the first thing you do after you set up your Uyuni server is you want to mirror your Alma Linux or Fedora or Debian packages. There's a command for this which is called space for common channels. Very great tool. So you just need to enter your API credentials and your distributions and the architecture you want to configure as channel. And then this tool does all the magic for you. And this is also consumable using this playbook. So in this case, we will have, after the installation, the OpenSUSE Leap 15.5 packages for the x86 64-bit architecture. Another possibility is to enable the monitoring right at the installation. So after the installation, you will have the possibility to consume Prometheus metrics for the Uyuni server, and it will also install the salt stack formulas for monitoring. So you can automatically, after the installation, assign the state to a system which will become the Grafana dashboard, for example. And after that, you might want to automatically register clients, which is the next example. You can see here, it's also very basic. We have a playbook which is assigned to the clients in our inventory. Of course, we have root privileges and we have the client role. And by default, it will search in the pub bootstrap directory of the Uyuni server for a bootstrap script which matches a naming scheme. So it should start with bootstrap, followed by the name of the distribution and the version of the distribution. So for example, bootstrap-alma-linux9.sh would automatically bootstrap the systems which are Alma Linux 9, for example. Of course, you can also choose different naming schemes, but I try to use best practices which are also mentioned in the SUSE Manager documentation. After having clients registered with SUSE Manager, we want to install patches, and for this we have a module which is called install patches. And what we do here in this example is that we assign the connection details. So we have the IP address or the hostname of our Uyuni installation. Of course, we have an API user we're going to use. So in this case, it's admin, I guess, like in every Hello World example out there. And we assign the name of the system we want to patch. So in this case, there's a server called myserverlocaldomain.log, and I want to install patches on this system. By default, if you don't specify any additional parameters, it will simply install all the available patches. So bug fixes, feature enhancements, security fixes, and so on. Sometimes you might want to control which patches are installed. And in this case, we have two parameters, include patches or exclude patches. So for example, if you only specify include patches, then only the patches listed will be installed. The other way around, exclude all patches except those mentioned in the list will be installed. So in this case, I have excluded two patches which are known to break the system, for example. And I don't need to worry about that. Simply run the playbook and all other patches will be automatically installed. As you see here, I assigned a single server name, which might not be that what I want to achieve using automation. Maybe I want to install all the patches on all the systems. So this is also possible with some Ansible magic. What we could do here is we leverage the dynamic inventory I'm going to show you in just a second. So we have a host group here, my servers, which is defined in Uyuni. And the install patches task is delegated to localhost, so to your Ansible host that's running the code. And we're doing a loop over the host group, which comes from the dynamic inventory. So it looks a little bit ugly, but works pretty good. So I'm using this to install patches on all the systems of an environment, for example. Let's say installing all the patches has worked. So the next step would be checking whether our OpenSCAP compliance is still in a great state. So of course there's a module for that. It's called the OpenSCAP run module. Like for the other modules, we assign the connection details to our Uyuni server. And we also specify the path to the OpenSCAP document we want to run the checks against. And we can also specify additional arguments for the OSCAP comment. So that's basically exactly the thing you do in the web interface of SUSE Manager or Uyuni, but in this case it's a YAML document with parameters. Speaking of the dynamic inventory, here's an example. So basically the inventory file needs to end with .uyuni.yml. And that's very important, like for any other dynamic inventory plugin for Ansible. Maybe it happened 2 or 3 times that I have been debugging for hours just to see that I fucked up the file name. So this is why I'm telling this multiple times here. Check the postfix of the file name, otherwise it won't work. So it's like any other dynamic inventory configuration. We have the plugin name specified here. We have the connection details, once again, IP address, hostname, user, and password. And we can also set show custom values to true, which will then present the custom values we can select in the Uyuni web interface as Ansible variables. So, for example, you can define backup variables or application variables in the interface of SUSE Manager and consume it as a normal variable in your Ansible code in order to make your patch management more flexible. You can also filter for IPv6 only if you don't want to deal with legacy network. Of course, you can skip SSL. And another thing we implemented is that you can filter on groups in Uyuni, or you can also filter for hosts that need a reboot. So for example, we have a playbook that reboots all the hosts that actually need a reboot. And to do so, you don't need to do any Ansible magic and check whether the API tells me that the system needs a reboot. We simply have another dynamic inventory that filters for all systems requiring a reboot, and one playbook just reboots all the systems in a lab environment, for example. So maybe let's see a short example. This is a screenshot of the Uyuni web interface. We have a particular system, as you can see here. Here's the host name, and we also have the custom system information I just told you about. We have a variable here called SUSECON system, and we have a value of 1. And running the Ansible inventory comment with the list parameter just lists exactly those systems. So we have the system, which is part of the test group that's defined in the interface of Uyuni. And if we have a look at the host variables, of course, we see the Ansible host variable, which is the IP address, and we see here the custom information that it's a SUSECON 23 system. And we can now use this in a role or in a playbook whatever we need it for. Okay, so that was a lot of theory. Maybe let's have a look at an example workflow. Somebody of you using AAP or AWX? Yeah? Okay, so this might be interesting for you. So usually patching Linux systems isn't quite as daunting as you might think. Installing patches is really easy. So running yum update or DNF update is really easy, but the problem is the preparation you need to do. For example, you want to make sure that your virtual machine has a snapshot, or maybe you want to run a backup before. Maybe you have a monitoring and somebody who doesn't like to get woken up in the night because the mobile phone is ringing because you forgot to schedule a downtime. and therefore we decided to create a workflow. So this is an example from one of our lab environments. We have VMware vSphere for hypervisor. I know it's a hard topic these days, but we use it in our lab. For monitoring, we have the Cfgmk open source software, and for the patch management, we are using, of course, Uyuni. And AWX uses various Ansible collections from Ansible Galaxy in order to automate the particular tasks. So we have the Cfgmk general collection for dealing with the monitoring downtime. We have community VMware for managing snapshots, and of course we have the Uyuni collection. And what the workflow will do, that I will show you in a couple of seconds, is it will schedule the downtime in our monitoring. It will create VM snapshots and afterwards install all the patches on all the systems, just by using one workflow with a single click and then watching and drinking coffee. So first of all, what you really always want to do is you want to pin versions when using Ansible collections from the internet. I hope everybody does this when you define projects in AAP. It's very important because, let's say, after half a year, there's a new version of the collection. Things might not work as you expected them. So therefore, we pin all the recent versions. I did this a couple of days ago, so they should be current. Of course, we install those requirements using the Ansible Galaxy collection install command. And the first playbook is how to install those patches. That looks quite like the stuff I just showed you a couple of slides ago. So I'm not going to show you how to schedule VMware snapshots and Cfgmk downtimes. That's very product specific. If you're interested into this, the first hit using your search engine will show you the working code. So we are using variables for the Uyuni access information. So we have a file that is encrypted with the API user and the network information. And we are delegating the patch installation to the control node, which might be a random container in this case. And we are looping through the dynamic inventory. We have the option in the workflow to just include specific patches. If no information is entered, then all the patches will be installed. And after that, we have then an OpenSCAP run. So again, we have the connection details and we have a OpenSCAP file that will be executed on all those systems. So the workflow looks like this, quite simple. First step would be creating a VM snapshot for all the VMs using the Uyuni dynamic inventory. The next time we are scheduling the Cfgmk downtime so that our colleagues won't get woken up in the night by emails or calls. Then we will install the patches that are available, and after that we run the OpenSCAP scan. So of course, I have also a video using this, so I'm not going to do this live because we know live demos never work. So here are some screenshots. So what we can see here, that the VM snapshot has been created. After that, here's a screenshot of Cfgmk that tells us basically that there's a scheduled downtime for 2 or 4 hours. So that window frame should be big enough in order for all the systems to get their patches installed and do a reboot. And we can see here also that we have an OpenSCAP scan that has been run. We see that patches has been installed. So we see that the playbook and the collection actually triggered all the API requests. And after a couple of seconds, all those workflows have been executed. And it doesn't matter whether it's one system or 100 systems, it's just one click and watching everything is done automatically. So the next thing I want to show you is Uyuni and event-driven Ansible. Who of you has already used event-driven Ansible? Somebody never heard about event-driven Ansible? Okay, so I will keep this short. So basically, event-driven Ansible, Ansible has been working reactively by now. So whenever a problem occurs, you run a playbook in order to fix it, like fry here, fix it, fix it, fix it. So, and one of the reasons why some people decided to still go for SaltStack is that they said, SaltStack is able to proactively react on events. So for example, let's say you have a very important database server and whenever the disk is full, then the database crashes and you need to do a restore from tape to ensure that all the data is in a consistent state. So before this event is triggered, the database server can send kind like SOS signal to the salt stack master. My disk is about to be full in a couple of minutes. Maybe you can give me some additional space. And this is what people also wanted to have for Ansible, and therefore event-driven Ansible was introduced last year at Red Hat Summit. So what does it look like? Basically, in addition to our playbooks, we have rule books. And in this rule books, we define events that should be monitored. So yet another YAML document, yay. And those events can be filtered, and we have actions that define countermeasures. So for example, if this gets full, run playbook in order to get additional storage capacity would be a solution for that problem. Currently, we have something around 22 plugins available called source plugins that handle this kind of monitoring and filtering. And the rulebooks are executed by a command which is called Ansible rulebook. This is also part of the recent version of Ansible Automation Platform. This kind of logic is executed in something which is called a decision environment, which is literally a Podman container with the Ansible content and the Ansible rulebook binary. So that's the current state. And we had a hackathon last year in our company, and we were tinkering around with EDA. And I just wanted to use this with Uyuni. So this is a really early stage. It might not be the best use case, so I'm interested in hearing what you think about this. So the proof of concept we did was we can react in real time on systems that actually require a reboot and trigger actions. As I said, that might not be the best use case. We just wanted to have any use case to see how easy it might be to develop your own event-driven Ansible plugin. So for example, in the demo I will show you, we have a host that gets a patch installed, and therefore SUSE Manager has a box that says the system needs a reboot because you installed a new kernel or whatever. And we, of course, we do not want to do this manually, because after patching 100 systems, I do not want to reboot 100 systems. So this could also be done automatically. I think there would be way better use cases for the future. So for example, let's say you have a system that becomes unresponsive, for example, because the network crashed or the system had basically a crash. You have a kernel panic, of course, your system won't be reachable anymore. So in this case, it would be possible to maybe execute a playbook that reboots the VM using your hypervisor API, for example. Yeah? Or another use case might be, let's say you have an automatic schedule of security using OpenSCAP, and at some time the security of a particular system becomes degraded because you installed new patches and they anyhow reduced your system security. Then you could automatically run an Ansible playbook in order to harden the system once again. So this is another use case we had in mind. But of course, we are open to hear your thoughts. So if you have any great idea or use case, just let us know. Here's an example. So this is a rulebook called Trigger Reboots, and we defined here, of course, the systems we want to assign. In this case, it's localhost because the system that runs the rulebook logic creates an AP call and reboots another system, so that can be run on the control node. And of course, first we simply dump the system name that will be rebooted, so it's just a debug message telling me the system of the event. So what you can see here, we have a variable Ansible EDA, event-driven Ansible. We have the event variable, and of course we have the host variable. So this variable contains a particular name of a system within Uyuni that actually requires a reboot. And after having this information, we can use the reboot host module of the Uyuni collection, which will then create an AP request to the Uyuni server to reboot this particular system. So independent whether it's a physical machine or a virtual machine. So very basic code. And this can be run really easily by running the Ansible rulebook command. Of course, we specify the inventory and we specify the rulebook. And then it will scan every couple of seconds. I think something around 30 seconds is the default, whether there are systems that actually require a reboot. And if this is the case, this is what you can see here, then we will have a message that the host needs to be rebooted, and it will also actually reboot the system. Of course, this is text. I could have faked this. So here's a screenshot that tells you that it's actually really working. So we have a system here. And you might know this dialog here that tells us the system requires a reboot. And by clicking the schedule a system reboot button, we could schedule a reboot. But Ansible is way faster here. So the rulebook found out that the system requires a reboot and actually triggered the reboot using a playbook that makes the API call. So, as I said, just a very basic example. There might be better use cases. We just wanted to tinker a little bit with EDA. So it's really easy to create your own EDA plugin. So in case you played around with EDA and there are some use cases missing for your purpose, it's not that hard. It's like writing an Ansible module. There are some examples available on GitHub. The documentation could be better, to be honest. But I wrote also a blog post where I share my thoughts on how I get started. You can also check this out. Okay, so the current release is the version 0.1.5, where we fixed some bugs and added support for new Uyuni versions. I think one of the next versions will have official event-driven Ansible support. So currently it's a feature branch. You can check it out and run the code and test it. And in one of the next versions, this will become generally available. And we also have received one of the first feature requests by a user, which would be having the possibility to automatically create bootstrap or activation keys. And of course, we are thrilled to hear your thoughts and ideas. So if you have anything in mind, just let us know. And here are some links. So here you have the Uyuni project page, the documentation, and that's the website about EDA. And here's the blog post where I share my thoughts, how easy it was to get started from zero with writing your own Uyuni EDA plugin. So I think we are finished with the slides. If you have any questions, feel free to ask. I hope that some information were useful for you. Thanks. Okay. Any thoughts, questions?
I was a bit confused that there was devil in the collection organization name. I was thinking, why would you not, if it becomes stable, you have to change. But then I noticed.
Yeah, exactly. Yeah. So the question was devil, whether it stands for development, but that's actually my handle that I have been using on all the social networks for more than 10 years. So
GitHub handle.
yeah. So yeah.
Okay.
I will forward with the company and.
Yeah. So maybe when this becomes stable, maybe we can move this to the GitHub organization of our company. Yeah. Yeah. Okay. Any other questions or feedback?
When you were rebooting the server, you triggered the reboot through unit.
Yes, correct.
Reboot directly.
The question was why we do the reboot using the Uyuni API and not the Ansible way. Both is possible, but the problem is that when we trigger actions like installing patches, running OpenSCAPscan, we rely on the Uyuni task scheduler. Yeah, so when you install patches and then schedule a reboot, then Uyuni will ensure that it will first install all the updates and after that do the actual security scan or the reboot. Because Ansible would be faster and it would simply reboot the systems in the middle of the patch management. And we had this with a system that had something around 600 updates. And after 10, it was rebooted and the system was completely doomed and we needed to restore it. Yeah.
Yeah, makes sense.
One of the things that I noticed is when you, for instance, you schedule the updates, you don't leverage the inventory. You use an inventory,
yes,
and you enumerate
to all the members of a group.
Yes.
So basically, you're parallelizing your deployment. Unless you change the way that your playbook is executed by default, you will run one iteration, you will wait until it's finished, possibly until your API query is
You mean this one here, the loop?
You run one iteration, it does one call to your API, it waits until your API comes back and tells you, okay, you do the next one. So basically, if you would upgrade 100 machines, you would have
be a loop.
a delay of maybe at least 100 seconds.
Yes.
So why don't you do it more in parallel instead of using, instead of enumerating the loop, replace your item with inventory hostname.
That would also be possible. And currently, name should be one particular system, but we also have a feature request that actually would replace this by multiple instances of hostnames, for example, or by simply a host group at all. So, and then we can send one API request that would schedule the jobs in all the systems, which is way nicer. You're totally right.
But the module is not waiting for it to be finished. That's the thing. It's just telling to Uni.
Do it.
Yes. Yeah, I don't know what the module behind is. I don't know how it functions.
It's just scheduled it, and that's why.
Yes.
It schedules it, but it's
quite
still,
fast. I would.
It still needs to wait for the return of the API.
That's true.
And waiting for a task is also a great idea. We also have a feature request for this, or a customer request, because sometimes you want to wait once the API tells you, okay, I received your request and I actually executed it and I can confirm that it's now finished. So we will also have a wait for tasks module.
And then you can do the reboot, because then you.
And then, exactly. And then we could have a wait module, and then afterwards using the Ansible way in order to reboot hosts. Exactly.
And then you circumvent the last part of Unity.
Yes, exactly.
If you want.
If you want.
Or you could add an argument to your install patches to wait until it's done for that particular host.
That's also possible. So I haven't decided which way would be the better way. So of course we could do this for every module that it simply waits. So that's sync instead of async. Or all the modules can simply return the idea of the task, and when you really need to wait for a very specific task, we have the wait for task module, and we have the variable with the job ID and can wait. I haven't decided yet. Okay, great. Any other questions or ideas? Thanks a lot. And have a lot of fun with the rest of Cfgmgmtcamp, I mean.
Unfortunately, it's not HTML.
I can check the mic level.
Okay.
Sorry, I didn't.
No problem. Is this on or still to be?
Speaker?
I think it's on. Okay, yeah. It's on.
Okay, yeah. And talk directly into the mic to make it
Maybe I can. Okay. Maybe it's easier now.
Okay.
Does it take it?
Yeah, I see the.
Okay. The signal.
Yeah, I see the bars and it's recording.
Yeah.
So yeah.
Okay.
Should be good. Are you ready?
Yeah. I mean, it's time. Perfect.
Okay, let's start. Okay, everybody. I lost talk. Studio government.
Thank you. So, hey everyone, we are going to talk about Ansible and security, supply chain security to be more precise now. Hopefully okay, it does work. So first of all, a little bit about automation supply chain, and then how to secure it, and then some conclusions around it. So about me, very quickly, I've been working since 2004, mostly in consulting roles. Ansible user since 2013, so it's 10 years at this point. And I've written a bunch of books on it, and I do work for Red Hat. So some quick disclaimers about this presentation. This presentation wants only to be a primer, not a full explanation. Security is a complex topic, therefore in 30 minutes it's not possible to go through the whole security things, but there will be a lot of links into the slides, and even more importantly, in probably the last slide, there is going to be the link to the slides so that you can then retrieve the slides and then click all the links easily. So supply chain attacks. Supply chain attacks are, they refer to malicious activities targeted to not a specific part, a specific chain, basically, but the moving of data in between passages of your supply chain. And this is a critical point because we are not going to secure the machine, we are not going to secure Ansible automation platform or AWX, whatever, but the movement of data in between all those steps. Why should people care about supply chain attacks? First of all, because they can be devastating. And I think one of the biggest reasons is that they are very difficult to detect. If they are properly done, you can detect them maybe months after they actually happened, because they are non-trivial to detect, at least. And also, it's hard to defend against them, mostly because we are not used to them. We are very used to secure single nodes, but not to secure the movement of data in between nodes. I mean, obviously we have HTTPS, all those kind of things that we have done it for many years, but those have a lot of assumptions that do not really secure too much around supply chain attacks. And also, they can have effects that are way wider than the single company that gets attacked. So if your company gets attacked, easily all your customer data might be compromised and your customer systems as well, and vice versa with your providers. And also, they are becoming increasingly common. In the last few years, we have seen a growing amount of supply chain attacks because they are fairly easy to do. I mean, they are hard to do, but still, they are easier than other kind of attacks. So why should we, as automation developers, engineers, care about supply chain attacks? First of all, because our code tend to run at very privileged level. So effectively, Ansible is useful if, well, there are cases obviously where this is not the case, but the majority of Ansible code runs as root, which means that as root you can do a lot of damages here and there. Also, a lot of Ansible supply chains are not very secure. So it's very easy to attack them, or easier to attack them. So if we look the automation supply chain, we need to distinguish the fact that there are different automation supply chains for different companies. So usually when people start with Ansible, that is how they do it. They are a developer on their machine, they manage nodes, they write code on their machine and then run Ansible dash playbook on their machine or Ansible navigator, and then just simply, get the configuration going and so on. But very quickly, they discover, or their manager discover, that model does not really work. So usually what happens is that these kind of scenarios start to happen where you have multiple developers, they do commits to a Git repo, and then there is the developer before that is still there and happy, and they run the SSH, the Ansible playbook commands, which does the SSH. Now, in this case, obviously, the situation is a little bit different, a little bit more complex, but still maybe manageable because we still have a human there running it. The problem is that human needs to go on holiday sometimes. So you start to have two humans there. And then even the other human needs to go on holiday sometimes, and then at that point you are like, well, maybe it's better to put a software there, and then you put a controller. And by controller, that could be AWX, can be Ansible Automation Controller, which is pretty much the same software, so or any other. But we'll be focusing mostly on AWX, AEC, because those are the ones that are more interesting probably for the conversation we are going to have. What happens then is that your developers discover that there are collections, and they can import collections, and very easily you will start to have a supply chain that becomes a little bit longer. Now, in this case, your developer will hopefully vet the collection that they are importing and targeting a specific version so that effectively at least that part is managed. Probably they will not. So that has some consequences. So first of all, if you find yourself in those kind of situation, it's probably better to start cleaning up a little bit your supply chain because this is very hard to make it secure. So how can we restructure it? With an automation hub, that could be Galaxy NG, can be private automation hub, same thing. And we can then import the collections there in a process that has some kind of policing around it. It can be very different kind of processes. You can automatically update them with approval steps. You can do weird things in between, but still, that you should do some kind of policing in that step. Another thing we can do is add a CI step in between Git and the controller, so that we can basically run some validation there as well. The easiest kind of validation that you should probably be running is testing, but we will see that we can also add some security steps there as well. And then probably you will want to have execution environments. When your setup becomes a little bit complex, execution environments can help you having a more stable environment throughout the life of your automation. So those can be improvements, but they are not security improvements. They are process improvements that will help you in a lot of cases, including security, but these by themselves, they will not add security to your setup. So what can we do to actually secure them? We have the same situation as before. The first thing that we notice is that we do have a Git repo, like here, and commits. So one first step could be to secure that part of the chain. So how can we ensure that what is in the Git is, or better, what is going to be pulled by the CI is the same thing that our developer actually wrote. And to do this, we can leverage the Git command, which is very helpful. It does has the dash capitalized S parameter where it can sign the message, the commit, sorry. Now, there are more details there because as every other part of this seems very easy, but you need to do a bunch of work beforehand. So for instance, every developer will need to have a key, an encryption key or a signing key. You will need to decide policies around those keys. What kind of keys do you want? Are those keys forever? Are those developers needing to change keys every so often, a year, 10 years, whatever? How do you roll those keys? How do you ensure that everyone knows the key of everyone else? Now, obviously, if everyone is in the same office, it's easier. But if people are scattered around, can be a little bit more complex. And if you have hundreds of people, it's obviously even more complex. So that's why the configuration of this needs to have a lot of thoughts into this. But in that page, you can find a lot of references around how to configure it and some consideration to make, or even links to those kind of resources. And then obviously we have signed the commits. So we have all the commits with every commit with their own signature. We need to validate them. And again, Git helps us. We have the verify commit option. And then you pass the commit ID, and it will validate the fact that it is signed. And you can also validate which key was used to sign it, and therefore if that key is valid for you or for your workflow. And then obviously there is a link for that as well. So if we implement this, so our developers effectively sign their commits and our CI validates their commits, we can secure that part of the graph. The green is not very clear, but hopefully you're able to see it. So obviously we can validate a lot of things here. For instance, we can have situation where people can directly push to the repo, so we can check that that person was actually allowed to put code there, or we can have some PR requests and then peer review, those kind of processes. All those things can be possible. And then obviously we'll need to write a CI that is aligned to whatever process we want to have. Another thing that we can do is to sign Ansible projects. Ansible projects in the sense of playbooks, basically, playbooks and roles. We can sign them. The way we do it is with the Ansible sign program. Project is the parameter, and then GPG sign, because we are going to use GPG here, and then the folder that the project stands in. More documentation also for this one. This is easily available. What it does is basically, creates a sign file, a signature file, and then adds it. You can also validate this as well, and there are multiple ways we can validate it. So first of all, manually, we can simply run Ansible sign project gpg verify dot, and then we will have a very similar output that we had with the git verify before. Or we can use AWX AAC user interface to actually do the validation. Now, if you do the validation with AWX, you can also force it so that basically only signed collection can be pulled by AWX/AAC. And then obviously there is the link for additional documentation about this. So if we implement this, this means that we can secure that chain in between CI and controller, because if we have the signature in the CI process and then the controller validates it, we can secure that link. Now, a question could be, why can't we have the developers actually put the signature? Obviously, that could be a valid option as well. So basically, we would not need two different ways of validate the things. The issue or downside, at least of that approach, would be that the developers could be somehow skip the whole CI process, which might not be what you want. So in this case, we are forcing basically the code to go through the CI and be validated up to the CI, and then from the CI to be validated again. Also, there is a potential security concern, which is how much do you trust your developers' machines? How much do you trust your CI machine? And if the answer is that you trust more your CI machine than your developer machine, then obviously you might want to have preferences there as well. Also, speaking about the developers, do not put keys on your people machines. Use hardware tokens, YubiKeys for instance, or other kind of hardware tokens, because developers' machines are probably not to be trusted too much. So what else can we do? Collections. We can sign collection and validate collections. So how can we do the signature part manually with GPG? Very easy, very small commands. Well, not really, but what we do is basically we create a signature of the manifest file. Nothing too fancy. But luckily, we also have Galaxy NG and Private Automation Hub that you have a UI, and if you configure it properly to actually do the signing as well, you can just click and it will do the signature for you. Also, both Galaxy NG and Private Automation Hub can have approval stages, either for pushing a collection during the push process of a collection, or during the sync in between different Galaxies, NGs, or Private Automation Hubs. And in that step, you can also add automatically the signature. So effectively, you can ensure that from that moment onward is exactly what you are expecting, and that that collection has gone through that approval step. And then obviously we can also import signature that got put in a previous Galaxy with the syncing process. There is the documentation as well there, and we can also validate them, obviously. Otherwise, it would not be very useful. So Ansible Galaxy can do the validation, very easy. Ansible Galaxy collection verify name, and it does the SSL, the signing validation for you. We also have Ansible build, because if you are building an execution environment and you are baking collection into it, probably you want to validate that the collection that you are baking into actually arrive from reliable sources, and that is the command. And also we can do the validation within AWX and AAP, and enforce basically the validation at that step. Links as well for that. So if we sign, we can at this point sign a lot of different things. So first of all, we can have the collections on the top that get signed if our provider of collections obviously signed the collections. If you are taking collection from random person on the internet, probably that's not very useful. But if you are taking them from a company, maybe a software provider, hardware provider, whatever, maybe they are signing them, that would be helpful. But also we can sign from the automation hub to the controller, and from the automation hub to the execution environment, basically. So we start to have a little bit more green. We still have one part that is missing, which is the execution environments. How can we be sure that the execution environments are what we are expecting? So Ansible execution environment signatures, very easy to do. You can do them in Scopio. Scopio is part of the Podman tool, or suite, better said, with a standalone sign, and then just sign the manifest file. Or even easier, with Podman, when you do Podman push, you can actually do sign by and then the email that is corresponding to a key. Obviously, you have to have a key configured on your system. It's also possible to do the signature manually on Galaxy NG or Private Automation Hub, or automatically when the images are pushed. So obviously, it depends a little bit on how exactly you produce execution environments. Some tools might be more useful to you than others. And there are a few links here as well. So on the validation side, there is a good thing, which is there is only one option. The only complex part is that it's not that straightforward because it is a Podman Docker container policy. Basically, what you can do in both Podman and Docker is create this policy, and then every container before is, well, after it's pulled, before it's run, gets through the policies, and if it passes the policy, then obviously it can be run, otherwise cannot be run. Now, the good part is that execution environments are containers, so effectively we can use this trick to do all the validation. But also for this, you can find more documentation there. So with this additional part, we can also secure the other two last components, which are the execution environment going back. So as you can see, we have now a lot of green here. Not everything is green. Obviously, there are some aspects that are still to be secured somehow. So one, for instance, is the connection in between controller and managed nodes. That is usually SSH, so hopefully it's already secure. There are many different ways to do SSH security, obviously. You can do the certificates, you can do PKIs, you can do many other things, but those are outside the scope of this talk. Also, another thing to notice is the fact that there are some components, so for instance, the CI component, the controller component, the automation hub component, which are basically hubs for those security links that we have created. So if those components are not secure, your whole chain will not be secure. So obviously, security is something that you have to do in depth. It's a layered model. So this is about the connection and how to make sure that the data do not change in between the change of machines. But obviously, all the other usual security tool suggestions and configuration are obviously to be done as well. So wrapping up, automation can be an interesting target for attackers and supply chain attacks as well. Automation supply chain tend to be long and complex. The one I've shown you is actually fairly short and simplified, but if you track your automation supply chain in your company, it's probably tens of steps long. It is critical to map your automation supply chain. That's the first step. Before doing anything, try to map the whole process and then eventually optimize it before actually securing it if you find very weird stuff. And there are many tools that can be used to help the security of your supply chain. With this, I leave you with these slides where you can find the link to those slides with all links clickable, as well as my contacts as well. And I think we have a couple of minutes for questions if there are any. Yes?
I think the most difficult is the fact that if you use collections, they might be signed, but you still have to trust that what is inside of the collection is okay. And that's the most difficult one, because the police officer there, I'm not sure if he's capable enough to check all the changes that have been made and check everything, in fact, and every time there is a new collection or a new update, usually this is someone from security that says, it's coming from Red Hat, it's fine. But then the question is your vendor, or maybe it's not Red Hat, maybe it's a community, or do they go to all the length to see if there is nothing compromising? And then the next thing is, this is just for the collections, but then we have the PyPy, the Python modules that are dependencies, and everything else that is inside of the execution environment.
Yeah, so it is true that we need to start from the assumption that this policeman is actually capable. Because if that person is not capable to do the validation job, then we have a very big issue. But as said, that is another weak link of the possible automation of the. If you blindly trust your vendor, that can be okay if your vendor is very trustworthy, but otherwise that might be an issue, absolutely. Your vendor might have a supply chain attack and ship you bad code. That can be.
Is Red Hat vetting all the packages that we pull in from Automation Hub from Red Hat? Are they all checked in depth, or is this also depending on?
So Red Hat does that, and also provides signature for that. But you know, it's a different company, and you need to trust Red Hat's processes. So it might work for you or might not. It really depends.
We already trust Red Hat because we have AAP, we have
Yes.
Automation Hub, we have Red Hat.
Yes.
I'm not sure if that is all.
Certified, they provide certification and what else to provide for
Yeah, but certification, for me, it's really that
auditing
all the changes. Yeah, but I don't know if it's really happening for everything, even the old code. And,
yeah, they have to because otherwise they lose the United States Department of Defense.
All big companies that are heavily certified usually have a lot of processes around that.
Yeah, but it's PyPy still in between. So
Yes. So obviously, when you create execution environments, you are importing a bunch of things. So, for instance, if you are importing RPMs, like installing RPMs.
From other vendors.
It depends where you are installing RPM, getting RPM from, but at least RPM have a good security model because they are all signed and verified during installation. PyPy depends. So
even signed RPMs from other locations. I mean, again, you trust that the content is what it was signed, but you don't know if there has been a.
Yeah, well, I mean, there you're back at, you mentioned that if you pull in stuff from random persons on the internet, it might not be signed. Well, if they're random persons, then there is a trust issue, probably.
Yes. Yes, yeah.
Even if they're signed, yeah.
Even if they're signed.
Yep.
Oh, they're signed by FUBAR.
Yeah, exactly. A signature does not guarantee anything to you other than it arrives from that person. That's the only guarantee that you have, but obviously if that person.
All of this less useful. I mean, it's part of the solution, but I think the biggest problem is where things are coming from sometimes and whether they.
I think that in the course of the next few years, there will be a lot more focus about these things because 5 years ago, I think no one was speaking about supply chain security. Now we are speaking about it. We have a lot of tools that do it. We have integrations as well. Many vendors are starting to provide signature for stuff. So
It's all about security awareness.
yeah, exactly.
It's even the commits of your own developers. I mean, if they pull it from random if they pull it from Google programmers somewhere and don't like what they copy,
turn off the internet, please. But that's what's happening. It's
we all look at the internet. It's not like we don't do it, but it's if you don't think while copying the stuff, and it happens.
Okay. Thank you. Thanks.
Here are your jackets.
Thank you.
Your names.
You managed to check. Copilot. Yeah.